Hello guys, good afternoon everyone. Welcome to the session and welcome once again to the GATE 2023 analysis, this time for the instrumentation branch. So ECEE branches were, exam was conducted successfully on 5th of February and this time it was a golden opportunity, of course for IN students but as well as for EC and EE students because the IN exam is on separate weekend, right? So definitely if you are an IN student, you must have appeared for the examination, and also I think many of the ECEE would have appeared, taking the advantage that the secondary paper is on the next week. So today we shall discuss that what is the level of the IN questions, weightage analysis and the detailed questions of this, sir.
Yes, this time we have a lot of data based on the experience students having on EC electrical papers. Now there are many similarities between EC electrical and IN papers, as you all also know. Nearly 70% syllabus is similar,
Yes,
right?
yes.
The extra few subjects are only there for IN students. So we have some data seeing the paper memory-based questions of EC electrical. So that may be very useful for analyzing IN paper as well and expecting how the questions will be. So let's see how the data is. We'll be going to present the data. So Ashu, what type of questions we are expecting? Any more data you have?
Sir, actually, if you look at, first of all, I want to discuss about the new subjects which are added.
Yeah.
So if you look at the electromagnetism and the electrical machines, so from past 2 years, the questions from electromagnetism and machines are not that much. Only 1 or 2 questions will be asked. But this year, I am expecting that they are going to ask more questions from machines and electromagnetism. So, signal.
Even MSQs also, we are expecting this time more, right?
Yes,
year
yes.
on year, this number is increasing.
And
So
in
first
fact,
year when MSQs are introduced, I think there are no MSQs.
No, IN it was there.
it was there,
Actually, ECEE no MSQ. IN was the only branch in our segment that produced MSQ question. Then I think next year, 2022, around 5 to 6
5
MSQs.
questions, I think.
So maybe this year we can expect 8 to 10 MSQs. So that is what it is. MSQs this year, almost every branch they are getting decent number of MSQs. First weekend हमने देख ही लिया है.
Sir, I think that the optical instrumentation part is more in sensor and optical instrumentation
So
part.
extra IN part, if we say approximately 25 marks it makes out of the 100.
Yes,
if you
yes.
count sensors, optical instrumentation, process control, measurement. So this accounts to around.
But I think this year, sir, it will be compensated. I think from these subjects, the questions will be less because electromagnetism and machines will also take some part.
Yes.
So I think they are going to
that's
ask
a
more
point.
questions
Yeah, that's a
from
point.
that.
So let's have a look into some of the previous data. And guys, I think the 12:30 time is crossed, and very soon maybe we shall start getting the questions.
We are expecting some questions from the students. We are in touch with the students as soon as they come out of the examination. So they'll share the questions and stay tuned to us. We are going to show you the questions, what level of questions and how the solution, what's the wrong answer, what's the correct answer. We are all going to give the details. We are all team is there here. So we are just expecting the questions very soon. Astosh, what's your opinion? Paper will be difficult or easy? Because the experience we have seen for EC electrical, compared to that, what's your prediction?
Thank you so much, sir. So guys, definitely the paper is going to be tilted towards the easier side if you compare it from EC and electrical. But sir, one important thing I want to mention here is that if you see the electrical and electronics guys, IN has become is a next backup, you can say, because if you have not performed well in your original main paper, then this is a big opportunity, because we have seen there are a number of PSUs and even the MTech programs which are giving slowly importance to instrumentation also, because instrumentation and process control is one major you can say structure which is very important to run a machine, to run a system.
Exactly.
Without this you cannot, because control system, networks, machine, whatever devices you are going to connect, ultimately if you don't have an instrumentation and process control, they cannot function coherently. So guys, keep on adding your friends and colleagues, because we are going to have a complete analysis for IN branch also today, and it is also going to be benefiting the other students who are going to appear for the next year, because they can have IN as their backup plan.
Exactly.
That is very
Sir,
important. That is very important point, that the students who are writing the exam will have definitely the curiosity how the paper was, but this session is not only for them, it is also for next year aspirants of not only IN again. It is for EC and electrical students also, because their secondary paper will be again IN, and there is high chances of getting better rank than EC electrical if you are performing the same level in both the examinations.
Exactly. सर मैं एक पॉइंट और ऐड करना चाहूँगा. सो स्टूडेंट्स, अगर आप कुछ कोर्सेज को देखें, जैसे ISC या IITs के कुछ कोर्सेज को देखोगे, तो स्पेशली जो इंस्ट्रूमेंटेशन के लिए जो कोर्स होते हैं सर, तो जिस स्टूडेंट ने बेसिक इलेक्ट्रिकल से है या इलेक्ट्रॉनिक्स से है, बट अगर उसने इंस्ट्रूमेंटेशन का एग्जाम दिया है, देन ही कैन ऑल्सो अप्लाई इन दैट कोर्स. एंड अगर आपकी रैंक
सम इंटरडिसिप्लिनरी सीट्स आल्सो.
Interdisciplinary.
अपने टाइम ISC में देखा था कि इंस्ट्रूमेंटेशन के टॉप रैंकर्स, एटलीस्ट सिंगल डिजिट रैंकर, दे आर आल्सो इन आवर डिपार्टमेंट, राइट? सो गेटिंग इनटू आवर डिपार्टमेंट थ्रू EC एंड EE एग्जाम इज डिफिकल्ट, बट वही बच्चे IN के थ्रू आ गए थे. और उस समय सर दो पेपर कॉम्बिनेशन नहीं होता था. दो स्टूडेंट्स स्पेशली सिलेक्टेड IN, कॉम्प्रोमाइजिंग EC. दे सिलेक्टेड IN बिकॉज़ वहां पे सिलेक्शन चांसेस ज्यादा होते हैं, एंड दे गॉट सिलेक्टेड इनटू ब्रांचेस लाइक माइक्रो इलेक्ट्रॉनिक्स, जिसमें मैं था, राइट? तो अब तो बच्चों के पास डबल अपॉर्चुनिटी है.
जो इंटरडिसिप्लिनरी जो खासकर ब्रांचेज है ना.
Sikandar is asking to share some important tips, last minute important tips. Ashu, please, from your side.
Last minute important tips.
He is having the
From
exam
my
second-
side,
second
I
shift.
think
okay,
my
okay.
side, it's very simple, guys, because just it is few second shift. What exam you are writing, Sikandar? Second shift is not for IN.
I don't think any major branch is there. What's your branch?
What's your branch, Sikandar?
Maybe
Whatever the
chemical,
branch, you
maybe
know,
chemical or something like that.
whatever the branch, Sikandar, stay calm. Focus on what you know only. Don't try to look here and there for new concepts to learn and all. Just focus what you learn and just recollect what you learn. Stay calm. And while writing the examination, always remember the first question, if you find it is difficult, it doesn't mean that all the questions will be difficult. You just move on to the second question. Even if its second question is difficult, move on to the third, fourth, fifth until you find easier questions. First go, you have to finish all the questions which are easier for you. So it's not that any exam, not only GATE, any exam will not have all the questions of very difficult. So definitely there will be 30% questions easier. So first finish those 30 questions so that your confidence will increase. By seeing the first few questions, don't get disappointed. So this is the very important thing, guys. Okay?
Exactly.
Correct.
Yeah.
So I think we
So
shall
let's
start.
see some analysis from the previous. Please come.
So guys, keep adding your friends, because this is going to be once again, as we have done in EC, electrical and mechanical and computer science, it is going to be one of the most authentic and most comprehensive complete analysis. We'll be coming up with all the subjects one by one. As soon as we are getting the questions, we'll be coming up with the questions. But before that, let us give you some idea about that what has been the pattern in the previous year as far as the IN branch is concerned. Rakesh sir.
So this is, sir, just to show the students before we get the IN paper. So this is just to showcase ki how this year electrical engineering was and electronics engineering was. So sir, electrical engineering, anyways, I think you have seen the entire paper. So what do you say for the
Yes, sir,
electrical engineering as compared to last year especially?
Yeah, electrical was quite a bit surprised this year, because for last couple of years we were having a easier side paper. You can say the difficulty level was not that much high, but this time it was a big surprise. Even though the question look very simple, but if you go to the solution, if you see the exact procedure, you will understand that how many multiple dimensions it is having. And there was very simple looking questions in, you can say, core subjects. But once we go through the complete analysis of the question, you will understand that it was more than the average difficulty level as far as electrical is concerned. Added layer was that this time, for the first time for electrical branch, MSQ questions came for the first time.
Yes.
And see, I think the next year we can expect more and more MSQ questions.
Every time it is actually happening.
Every time it is happening.
Right. So this year, last 2 years, electrical, there was no MSQ. This time, suddenly 8 MSQs.
8 MSQs.
Right. So,
And
yeah.
sir, one thing more. I have seen the questions for MSQ in electrical paper, and really, as we were discussing in multiple sessions already in our YT channel, that MSQ questions are really going to be checking your fundamental concepts.
Yes.
It's not that easy that you have to choose A, B together, A, B, C together, because beyond that, if you don't understand the core concept, you will not be able to handle the MSQ question.
Correct. So this was the weightage distribution for electrical engineering. So sir, whether it was normal as compared to last year, yeah, any changes in the weightage as well?
So there was not a significant change. We have seen that for power system and machines, the number of questions were little less because in the previous year we have seen it was around 8 to 12 questions. For example, in power system 2020 they have asked around 12 questions, but this year it was only 6-7 questions. But we have seen some of the subjects like electromagnetics and measurement, they have got some little more importance this year. If you see EMT, the weightage has been increased 5%. Even though for measurement it was same, but EMT it was little increased. But if you see the subjects which are mathematical in nature, for example, signal and system have
This time
we
increased.
have got good quality questions. Control system we have got
And power
good.
electronics slightly reduced.
Cited number of questions were reduced. This was a bit surprise because over the years we have seen a pattern that power electronics is at par with machines and power system, but this time there were only 4 questions, sir.
Correct, sir. So looking into electronics, we will say as compared to last, because last 2-3 years electronics papers was little challenging, little on a tougher side, but this time relatively easy. I don't say much easy, relatively easier, right? Only the good part in the electronics paper was questions from EMT. Rest questions were very regular, very regular. ठीक है, तो EMT का भी tough नहीं था, but they demanded some basic concepts, basic fundamentals जहाँ पे आप फंस सकते हो. MSQ in electronics went down because last year suddenly electronics received huge number of MSQs. There were 14 MSQs last year, but still this time there are 4 MSQs. The MSQs are there this time. Till now you can see computer science, mechanical, electronics and electrical. We have seen MSQs, right? And I think Engg also has seen MSQ. Our parallelly Engg session also has started. And this was the weightage distribution. And in electronics, as far as the weightage is concerned, I'm not surprised. Maybe 1 or 2 marks fluctuation in some subject, but not a major change, right? And I think electronics में हर बार एक trend होता है. Like sir, in electrical we have subjects like measurement or EMT or analog or digital individually. If we take, they are always around less marks, 4, 5, 6 marks. But EC, rarely I find any subject which comes for 4 or 5 marks. Almost subjects in EC are 7 to 8 marks or 10 marks. And it's similar pattern, 1 or 2 marks plus minus होता है, तो that is, you know, always expected. इतना change के लिए हम ready रह सकते हैं, right?
So guys, keep adding your friends. Finally, we are about to get the questions in front of your screen. So be there, stay there.
Okay. Okay, and I have also got, acha nahi, this is what?
And we are coming up with the weightage analysis also, friends, that how many MSQ has been asked, how many MCQ and NAT questions have been asked, and we'll be very soon coming up with the solutions also. What is the authentic key and solution?
All right. So, sir, what is the data you have got? Please, if you share us. So, guys, yes, MSQs are coming up. I think surprise for instrumentation once again.
Yes, sir. MSQ actually it was opposite as we expected. MSQ number of MSQ is only 1, and MCQ I think 31, and that NAT questions are 33 approximately.
The NATs are more again.
Yes.
Sir, I think this MSQ will always play with the emotions of the student.
Yeah,
because
like in
when we
Insta,
are-
I told you last year 14, suddenly this time it is 4. Okay, so go with some expectation of MSQs, right? It may go up and down, definitely.
But it's not the final data, sir. I mean, just
This is, memory based.
because
data.
it is memory based, so we are still expecting some more data.
Sir, some students are saying machine से एक ही question है. Only one question from a machine.
One question per machine. Because if you see the previous year pattern also, we have discussed the weightage. We were discussing the weightage that machine is getting less questions. But definitely, sir, I think in time to come, as you were saying, that definitely machine will be getting more and more impact, because it is a very core subject, and without machines, without discussing machines, for example, if a simple process control you have to operate. So without a machine, how you can do it? Exactly. You require a transformer. If you don't know how a transformer works, you will not be able to do the sensor part.
Yes, exactly, sir.
Yes,
Exactly. Moreover, I think machine is less because it's not the core part of. I mean,
Yes.
it's important for instrumentation, but it's not the core part. And moreover, if machines, I mean, if the number of questions in machine are at higher end, then the difficulty level will always be increased.
This is what you just told, I think. This is the weightage.
Yes, exactly, sir. One
31
MSQ,
MCQs,
31
and 33 NATs. Okay, this
exactly.
is what is the data of 2023 that we have got. We are still checking it up. We are Yes, sir. Same thing I have got again from one more data. Yes, MSQ1, MCQ
31,
and
NAT 33.
So, INE students, I think you must be taking a breath of relief because only one MSQ question, and I think it is going to be the most tricky question.
No, the next important thing is machine carry only one question.
Only one question. I think maybe that is MSQ. Maybe that is.
Yes.
और सर कोड से ज्यादा है बच्चे कह रहे हैं कि इंस्ट्रूमेंटेशन के कोड से ज्यादा है
Instrumentation core, we have got good
Sensors
amount of
and process controls.
questions. So, guys, over to you, sir.
Can we say based on this MSQs are only one? Can we say is it little easier than
Yeah,
last
we
year?
can say, we
Because
can say.
MSQs are having more ambiguity.
But it's not the only criteria, sir. But definitely, if you have less number of MSQs, because MSQs, until unless you have a complete understanding of the core concept, you will not be able to handle it. Because there are multiple dimensions to anything. And the language, so there was one question in power system. I think there was unlimited time. We have discussed that question, and you also did it. I also did it. That there are every single statement they have added the word only. And if that only is not added, the answer would have been different. So hours and hours we discussed, and finally we have put up with the question on.
No, actually, the basic funda behind the MSQ is again the same. Na? They are checking your understanding behind the concept. Because if you are solving a numerical question, and if I give you some 3 parts in the numerical, and I ask you calculate the current and voltage and power, then it's no point of asking, sir.
Yes.
The MSQ is the idea behind the MSQ is they want to check your conceptual understanding. That's why the MSQ question is usually it come theoretical. So that's why in electrical MSQ were very, very good, sir.
Yes.
And in electronics also there were some good questions in MSQ part. So
The same thing.
So one way we can say that EC students and electrical students who are opting for IN maybe finding it is easy compared to.
So guys who have attempted the IN paper, and if you are live with us, can you give us your feedback? What has been your
share
experience?
your experience and comment on the MSQs, MCQs,
Yeah.
and the difficulty level also, so that we'll share it to other students who want to know the common opinion. Because after the examination, some students will be having some doubt that only I have done well or only I have not done well, or others are also, because it's a competitive exam. It's not only on your performance, it is also about others how they have performed. So based on these 2 parameters, your rank and score will be. So we are also curious how we have performed and how others must have been performed.
Definitely,
so this is
sir.
also important.
So there is one added layer as you were talking about MSQ. That NAT questions, I find it in the second category, because NAT questions you don't have a reference.
Exactly.
And because you don't know in which direction you are going, that is correct or not, because you are getting the answer, then you have to be having 100% confidence that this is the correct answer. Sometimes it is very easy question, and because you have done a simple mistake in the calculation, you may be getting the wrong answer.
Correct.
Exactly.
So number of NATs, sir, if we see this year, I think it is 33. So you can understand that one MSQ, but at the same time, the balancing act is that NATs are significant in terms of MCQ. So I think, sir, more or less it is going to be an average side. On average side, it is going to be. But let us see from the student side.
The next important thing is, sir, they ask from the core part, I mean the optical instrumentation and sensor part. So for electronics and electrical student, it will be difficult to solve for them. So I think it's a bad news for electrical electronics student. But no worries, guys. I think because the number of students are less, if you know the basic concepts, then I think you can attempt the question. So we are also getting the question. So soon we'll start solving the questions.
But sir, it will be same. But it will be, for example, if EC electrical have to fight together, then that problem is going to be same for everyone, and you have to fight for only the common subjects.
Yes,
So it is going to be relative, so not to lose your heart, because still if you are not getting a very good score, if the difficulty level was high, still with less marks you may get a good rank.
Yeah.
That is one possibility. Sir.
Some students are asking about the exam level. Guys, still we are waiting for the questions. Until unless we see the questions, we can't comment on the difficulty level. But you guys already have seen, and share this information that this session is live already, and ask the students to comment in the chat box about the difficulty level, so that by seeing the comments we can also come to a conclusion. By the time if we get some questions, already our faculty are waiting for questions, and some questions if they are received.
Sir, as we can say, 4 years se aaya MSc question. There is one question.
Okay.
Yeah, Piyush is saying it is easy. Okay. Piyush perspective, it is easy. Basic question on MSQ, it was easy. Very good. So that's a good news.
And the MSQ
Yeah.
question was from Fourier.
4-year transform.
Fourier transform. Okay.
Or as you can
That's
see,
good.
sir, Thevenin say there is one question, and we have observed from electrical EC also that Thevenin's theorem is an important concept. They have also one question in electrical.
And it is
one
basic
in
also.
AC.
For any engineering graduate, Thevenin's theorem is the basic from networks you have to learn. And if questions are coming from that, that means you should be comfortable with that. आज का क्वेश्चन आशु जांगरा वाला था नेटवर्क में. Very good guys. That's a good news that students following us getting the questions and benefited.
So
That's
it's
very good
not,
news.
it's not just in IN, I must say, we have got the same response in EC, electrical and mechanical CS also.
Yeah.
When we were doing the analysis, we have got the information feedback from our students that lot of questions have come up from our marathon sessions that we have taken.
Many students got benefited from
Yes, sir.
marathon sessions. That is the purpose of doing marathon sessions. So follow us as and when it is required as per the time. So just before the exam, to revise all the things in very less time, we are going for marathon sessions which are useful. Last year also many students got
Questions?
yeah.
So
Yeah, please. Yes, guys, we got
So
some
guys,
questions
keep
and
keep
know the
adding.
answer. If you are curious to know the answer, how the question and what type of question, Ashu Jangre sir received one question from the students. They have shared their memory base. Please confirm the question.
So guys,
and know the answer, guys. Carry on.
yes, I got the questions from network theory, and it's from transient. So let's try to solve this question. Okay. So let's try to solve this question, guys. The question is, there is a current source which is provided to you, and the current source has the value I naught ut, and there is a resistance and inductor in parallel. Resistance, and there is one more inductor in parallel. Okay, and it is given that the resistance has the value 10 kilo ohm. It has the value 10 kilo ohm, and inductor has 1 millihenry value. Now, at t equal to 0, this current source is applied. Obviously, it will start from t equal to 0 onward. The question asked is the minimum time taken for the current through the inductor to reach 99% of its final value. Okay, 99% of its final value. So, can you write the current equation in this inductor? Can you write the current equation in this inductor? So we can use the direct equation for current. We know that the initial current in the inductor is 0. Initial current is 0. There was no initial current in the inductor because the source was not present. And the steady state current will be equal to I naught itself, because it will behave like shorted. It will behave like short circuit. So the entire current will flow through the inductor. So I steady state will be I naught. And the time constant will be equal to L divided by the Thevenin resistance. So L is 10 raised to power minus 3 divided by the Thevenin resistance. If you look at the Thevenin resistance from these two terminals, the Thevenin resistance will be 10 kilo ohm. So it will be 10 raised to power 4. Okay. So the time constant came out to be 10 raised to power minus 7. 10 raised to power minus 7. Now we can write the current equation. IT will be equal to I infinity plus I0 minus I infinity e to the power minus t by tau. So it's a simple question. Now you can write the direct current equation. So the current equation will be equal to I infinity is I naught, okay? I naught plus I0 minus I naught. I0 is 0 minus I naught e to the power minus t by tau, okay? Now you can simplify this. I naught is common, 1 minus e to the power minus t by tau. We need to calculate the time by which this current has reached to the 99% of this value. Let me check whether it is 99 or 90. I think it's 99. Okay, so that must be equal to, we need to calculate the time in which this current reached to 0.99 I naught. 0.99 I naught. We can calculate it easily. Just this I naught is cancelled, and you take this 0.99 on this side, 1 minus 0.99. 1 minus 0.99 is equal to e to the power minus t by tau. Now you can see that this difference will be 0.01. 0.01 is equal to e to the power minus t by tau. So t is equal to ln minus tau ln 0.01. You can see that I have taken ln on both sides, okay, and then multiplied by tau. So this value came out to be
4.61.
4.61 second.
Multiply by tau.
Okay, multiply by tau, and the tau value is 10 to the power minus 7. So the answer will be 4.61 into 10 to the power minus 7. You check the calculation, guys. Okay, please check the calculation. I think the answer should be like this. Okay, ln 0.01. You just calculate this value, and since the value of this ln will be negative, and there is one more negative sign outside, so it will become positive. You put the value of tau. Tau is 10 to the minus 7, and you will get the answer. Okay, so this was an easy question.
Sir,
Okay.
Can we check? One student is saying that initial current is I naught by 5. Right,
Okay, initial current, I think initial current is not provided to me. At t minus 0, there is a current, okay, there is a
I naught by 5.
current of I naught by 5. Okay, I thought that this current is I naught by s, because the Laplace is, because the 5 I suppose that it is s. Okay guys, so the initial current in the inductor is also given. So let's try to solve it again, because I thought that this current, the Laplace of this current is given. That is I naught by s. I confused with the s and 5. Okay, let's come to the next question. I mean, let's try to solve this again. So let's come to the next slide. Okay, let's try to solve it again. So now the initial current is also given to you. This is I naught by s, and there is a resistor again, and I have an inductor. In the inductor there was an initial current, and the initial current given as I naught by 5. I naught by 5. This is my I0. This is the initial current, and the steady state current is again, under steady state it will be sorted. So steady state current will be I naught. Okay, I naught. So don't confuse with this 5 and this s. Okay, so in time domain this current is I naught ut. Okay, I have written it in Laplace domain. So the initial current in the inductor is given as I naught by 5, and the steady state current will be I naught itself, and the time constant, we have already calculated the time constant, that is 10 to the power minus 7. Now we can write the current equation it as I infinity plus I0 minus I infinity, I0 minus I infinity e to the power minus t by tau. If you calculate this, take this I naught common, and it will be 1 minus 4 by 5. 1 is common here. 1 minus 4 by 5 e to the power minus t by tau. I think this is the equation for the current. Now you put it equal to 0.99 I naught, 0.99 I naught, because we want the time in which this current has reached to 99% value of the steady state current. So we can put it equal to 0.99 I naught is cancelled. Now you can see that 4 by 5 e to the power minus t by tau is equal to 0.01. Now we take ln, and t will be equal to minus tau ln.
So 4.38.
You can calculate this value, no?
After
So
ln, it is
0.05 divided by 4. I think this is correct.
Yes, sir.
Okay.
4.38.
So this is equal to 4.38 tau. Okay. So this is 4.38 tau, guys. I think this is the correct answer now. So you can check the values, and I think you can check the calculation also. I have done everything accurately. So let's move to the next question. There is
One question I got from machine.
okay. So Ashutosh sir will solve one question from electrical machine. So sir.
So guys, I hope you are enjoying the analysis, and I have seen the machine question. It was quite a tricky question. It was an NAT question. So I will just tell you, it was quite easy. The question was saying, if any data, any statement is wrong, what I'm saying, you please correct me. You can tell me the feedback in the comment section. So the question was something like that. There is a DC shunt generator. This is the situation. Suppose I'm taking randomly. It is not given. Number of poles are not given. And suppose this is north pole. This is south pole. It was a DC shunt generator, and the rotor was rotating in the clockwise direction. Now the question is saying, at no load, the terminal voltage is 200 volts. And the question is asking if the direction of rotation of the rotor is reversed. In the opposite direction, if it is rotated, then what will be the output terminal voltage? Now it is a tricky question. Now please understand, it basically belongs to the DC shunt generator voltage buildup. There are some conditions. How voltage is going to be built up in a DC shunt generator. Suppose this is the excitation, and it is something like this. It is something like this. Now this EMF, which is because of the remnant flux in the poles, it is required to develop the voltage at the terminal of the generator in case of a shunt generator. Now, if you rotate the generator in the opposite side, that is going to kill this voltage and the generator will not be able to build up the voltage. So the final answer for this NAT question is going to be 0. It was quite a tricky question. I think if you start solving it with the equations. You got one question, sir?
Yes.
So now again Ashu sir is coming up with one question.
Okay guys, I got one question from network theory again, and again the question is very simple. It is based on resonance. So let's start solving that question. So the question statement is, you can verify that statement also. There is a circuit which is given to us, and the circuit is like this. There is a voltage source here in series with a resistance of value 25 ohm, and we have an inductor, and the inductor value is 1 by 20 millihenry, 1 by 20 pi millihenry, and there is a capacitor and one more resistor. There is a capacitor and one more resistor, and the capacitor value is 1 by 20 pi millifarad. Okay, and the resistance value is 25 ohm. Again, it is given that we have a voltage source of 10 root 2 sine of omega t, and omega is provided as, omega is given as 20,000 pi t, 20,000 pi t. Please check it. So the question is, the voltage source has an internal resistance of 50 ohm. The voltage source, and it is given as R. Okay, this 25 ohm is given as R. It is given that the voltage source has internal resistance of 50 ohm. The RMS value of the current through the R in milliampere. Okay, we need to calculate this RMS current. Now, how to calculate? We know that there is an internal resistance of this source. So let's connect an internal resistance. So the internal resistance, I have to connect it here because 50 ohm is not given anywhere. Okay, 50 ohm is not given anywhere. I think this is the circuit provided, and this source is represented including its internal resistance. Okay, so the internal resistance is given as 50 ohm. So let's provide it, let's write it separately, because there is a confusion. I don't know whether it is correct or not. I think it might be possible that this circuit is not provided you in the question. Please verify that, because this 25 plus 25 is again 50. So he can take this 50 as internal resistance also. But I think it is given separately. If it is given separately, then internal resistance has to be 50 ohm and you have to show it separately. I hope it is clear. Okay, so let's take it 50 ohm. Okay, now first of all, look at this frequency. And what is the resonance frequency of this circuit? Let's calculate the resonance frequency first. So the resonance frequency is 1 by root LC. 1 by root LC. This much of radian per second. Okay, now let's calculate this value. So 1 by root of L. What is L? L is 1 upon 20 pi 10 to the power minus 3 into C. And the C value is again 1 by 20 pi into 10 to the power minus 3. So the frequency came out to be 20 pi into 10 to the power 3. This is my resonance frequency. And luckily, the same frequency is provided for the source. It means this circuit is under resonance. If it is under resonance, now the reactance of these two, inductor and capacitor, will cancel with one another, and the total current will be the RMS voltage divided by the total resistance, because the reactance of this inductor and reactance of this capacitor will cancel. So the current, RMS current, will be the RMS value of the voltage source, which is 10, divided by the total resistance, and the total resistance is 25 plus 25 plus 50. So it is 100. So the answer has to be equal to 0.1. Okay, 0.1 ampere. Now, answer is 0.1 only if I am taking 50 ohms separately. So be careful, because I am not aware of the question. So I think it is not provided in the question. If in the question, if he is saying that this 25 and this 25 is the internal resistance, then we don't need to connect this extra 50. Okay, just be careful. But because I'm not getting the question correctly, so according to my understanding, this should be the correct answer. Okay, so let's come to the next question. There is one more question from network theory. Again, it's based on resonance, sir. I think it's a resonance. So let's try to solve that question also. The next question is, we have a circuit R1. We have a circuit R1 and L. There is one more resistor R2 and a capacitor C. Okay, and that is variable. The C is variable. Omega is given as 100 pi. Omega is provided as 100 pi. R1 equal to R2. R1 equal to R2 equal to 2.2 ohm. It is given as 2.2 ohm. L given as 7 millihenry. L is provided as 7 millihenry. The capacitance C, for which the admittance is purely real. We need to calculate the capacitance C so that the admittance of this circuit become purely real. So it's very easy question. What you can do is, you can calculate the admittance of this part and the admittance of this part, and then add and make the imaginary part equal to 0. So let's calculate the admittance of this branch only. So the admittance of this branch will be 1 by R1 plus j omega L. So R1 is 2.2 plus j omega. What is omega? Omega is 100 pi. Omega is 100 pi into L. L value is 7 millihenry. 7 into 10 to the power minus 3. Okay. So this is the admittance of this branch. Okay. What is the admittance of this branch? Tell me guys. It is 1 over resistance of this branch. Resistance is again 2.2. 2.2 minus j by omega C. Omega is 100 pi. Omega is 100 pi into C. The C value is C value. Okay, C we have to calculate. Okay, so this is the total admittance, guys, and we know that in parallel admittance will add. So I have added these two admittances. Now what I need to do is, I need to make the imaginary part of the admittance equal to 0. So if you make the imaginary part, let's calculate the imaginary part. So the imaginary part for this quantity is minus j 100 pi. I am writing it directly. Okay, into 7 into 10 to the power minus 3. So this is the, and divide by 2.2 square plus, what is the square of this quantity? What is the square of this quantity? Square of this quantity is, you can see that it's 0.1 pi. 0.1 pi into 7. 0.1 pi into 7. If you can calculate this value, 0.1 pi into 7, and take the square of that and take the root. Okay. This is the imaginary part of this admittance. Okay. Now what is the imaginary part of this admittance? So let's calculate the imaginary part of this admittance also. So it will be j divided by 100 pi into C divided by root of 2.2 square plus 1 upon 100 pi into C, and take the square of that. Okay, so this is the imaginary part of this admittance. I have written it directly. Okay, I have not done the realization process, so I have written it directly. So this is the imaginary part of this admittance, and this is the imaginary part of this admittance. Now we know that it has to be 0. So what we can do is, we can make it equal to 0. So let's make it equal to 0, and now we have to calculate the value for C. So how to calculate, guys? Tell me. Now if you can simplify this, this j will come on this side, so it will be 100 pi into 7 into 10 to the power minus 3 divided by root of 2.2 square plus, can you calculate this value, sir? If you can calculate, this value will be 0.1 pi, 0.1 pi, let me rub it. Yes, 0.1 pi into 7 and take the square of it.
4.83.
4.83. Okay, so this value came out to be 4.83. 4.83 square of that. Okay, so is equal to, now I have taken this part on this side now is equal to, let's calculate this value also. So it will be 1 upon,
So after square it is 4.83.
after square it is 4.83. Okay, so after square it is 4.83. Thank you. 4.83. And what is this value after square? 2.2 square. 4.8. So they are equal. They are equal. So just multiply with 2. Okay, so let me multiply it with 2. So it will be 4.84 into 2 and take the root of that. Okay, so please calculate the root also, and let's calculate this entire value.
3.1.
So
Root 3.1.
Okay, no. It will be cancelled, no? So it will be 0. If you look at the numerator part, it will be 0.1 pi into 7 divided by 4.84 into 2 and take the root of that. Okay, so the numerator will be again 4.84. The numerator will be again or maybe 2 point something. Please tell me the numerator value. So guys, the only thing is you have to calculate. The only thing is calculation part. Nothing extra you have to do.
19 numerator.
Numerator is 2.19. Okay. In the denominator, you have 2 into root of 2.19. Okay. So the value came out to be this right hand, this left hand side came out to be 1 by 2 root of 2.19. Okay. What I have done is I have broken this part in two parts. No? I think it is correct. It's not correct, I think. Okay, wait. I have done the mistake in the calculation. So anyway, let's calculate this value, guys. Please tell me this value because it will be more useful. Now in this side, on the right side, let me write the value on the right side also. So it will be 1 by 100 pi c. Okay, this came out to be 0.71. And on the right side, you can see that it will be 1 upon 100 pi c, 1 upon root of 2.2 square plus 1 upon 100 pi into c and take the square of that. Okay, now we need to calculate the value of c. I think it's easy peasy. You can assume that this value is x. Okay, let's assume that this value is x. So 0.71 is equal to 1 divided by x into root of this is 4.84 plus x square. I think it is clear. Now you can take the square on both sides and calculate the value of x. Once you get the value of x, x must be equal to 1 upon 100 pi c and we can calculate the value of c. If my calculation is correct, this question was nothing, just only you have to do the calculation part. Okay, so let's take the square of that. So 0.71 square is equal to, on this side you have 1 upon x square into 4.84 plus x square. Okay, so this is the equation now. Now take this on this side, and 0.71 square is 0.5, I suppose. So it will be 0.5. So if you take this on this side, so it will become x square into 4.84 plus x square is equal to 2. Okay. If you take the inverse of that, this is 0.5. 0.5 inverse is 2 again, and the inverse of this is x square into 4.84 plus x square. Now you can calculate the value of x square. This is a quadratic equation. You can write x square equal to p. So it will be p square plus 4.84p minus 2 is equal to 0. Now you can calculate the value of p. From p you can calculate the value of x. From x you can calculate the value of c. So let's first calculate p. P came out to be 0.
Final answer 0.78.
Okay, final c value. Yes. Okay, so final c answer came out to be 0.78. Okay, so a final answer came out to be 0.78, guys. Please check the calculation because the concept was very simple. Okay, we need to make the imaginary part of the admittance equal to 0. So we have calculated the imaginary part of this admittance and the imaginary part of this admittance. Okay, make it equal to 0 and then calculate the value of c. I think it was easy peasy. Okay, let's move to the next question. Sir, okay, which subject?
So networks.
Network theory.
One more question of network. So, like 2 questions. So guys, I have one question of network, right? And it's easy question. It's from Thevenin's theorem. Okay, let's solve this question. It's from Thevenin's theorem. And as you have seen, Thevenin's theorem question that comes out this year in IN exam is very, very simple. It's just an independent source are given, no need of dependent source. So let's solve it. So according to question, if there is some mistake in data, you can tell me, guys. Okay. So bacho, according to question, this is given. Okay, we have given a voltage source, a few resistance, current source, and much more. So let me draw the circuit. So we have given a terminal AB where this is 1 ohm, this is 1 ohm, 1 ampere, 1 ohm, 1 ohm, 1 volt, and 1 ohm. And according to question, we have to find out RTH. Okay, so just like Ashu sir said, it's an easy peasy question. So here we have to find out the RTH. So if I'm not wrong, this question is for 1 mark, right? आप लोग बताओ मुझे 1 mark का ही question होगा ये, उससे ज़्यादा का important है भी नहीं है. So here you can see we have given a voltage source. So what I can do? I can short circuit the voltage source and open circuit the current source here. So short circuit the voltage source and open circuit the current source here. Then from a terminal AB we can find out RTH, right? So simply you can say this 1 ohm resistor is now open circuit, there is no use, and here you can see this will be short circuit again, so this will not come in picture. So finally we have the series of 1 and 1 ohm parallel with 1 ohm. So final answer for RTH will be equal to 1 plus 1, which is a series combination here, parallel to 1 ohm. So 2 parallel to 1 is equal to 2 multiplied by 1 divided by 2 plus 1. So it comes out to be 2 by 3, or I can say 0.67 ohms. So tell me, the same answer you got, yes or no? According to the data we have, so we got 0.67 ohm, and it's very simple question. And till now you have seen that we have discussed at least 4 questions from a network theory. So here you can see network theory comes out for good marks compared to your other subjects. So let's give one more question. I have also one more question, and simple question again, 1 mark question hai. This is a question from analog electronics, or you can say networks also, simple here. So we have given half wave rectifier actually, and here we have a resistor here, and here we have a current source. So according to question, this current source is pi sine 3000 pi t, okay, and diode given is ideal. And according to question, we have to find average current. This is milliampere, okay, this comes out in milliampere, and we have to find average current, okay. So I guess this is the question. Again, bacho, if there's a mistake in data, you can tell me. Okay, sir, one resistance also there in current source. Beta, are you saying here? Data is wrong. Tell me, beta, what is data? One resistor is also there in a current source. So is it parallel or in series? Can you tell me? Is it in parallel or is it in series? Rityaksha and Kaipi. Tell me, parallel or series? Previous question. Okay, let me see. Previous question. There is a one current source here, na? Here you can see, bache, there is a one current source, na? As you can see. But since we are finding out RTH, so that current source has been open and that has been removed. बेटा current source को आप open करोगे तो यहाँ से open हो जाएगा तो 1 ohm आपके picture में नहीं आएगा ना. And this particular 1 ohm is also short circuit because we had a voltage source here, so we have short circuit the voltage source. है ना, open circuit and short circuit. Remember, simple concept ना. Why you are getting confused? There was 2 current source. Okay. Let me see. When we got the correct diagram, then I will discuss again if there is 2 current source. So here we have to find out the average here. So average current, simple hai, half wave rectifier you have and the diode is ideal. So average current is equal to simple, it's Im by pi. It's Im by pi. Here you can see Im is pi here, divide by pi, it comes out to be 1 milliampere. Again, don't worry, if there is a wrong data, you can tell me. Okay. Achha, you are saying there is a 2 parallel. Data missing maybe. Okay, let me check. Okay, fine. There is a 2 current source. We have get a question again and then come to that particular part. Okay. Now Rakesh sir will come and he will discuss the remaining questions.
Okay. Thank you, sir. Thank you so much. All right, guys. So, few more questions we shall now discuss here. Let us take few more questions. So, dear, we have now the question from mathematics, engineering mathematics, control systems, and digital electronics, right? Okay, some of the questions based on this. Chalo, so let us get started. And as far as I have seen the paper till now, at least for the common parts, be it maths, control, and digital, it's extremely simple. It is extremely simple paper. Are you able to listen to me? It is an extremely simple paper. So now question number 1, x is a discrete random variable which takes the value. They are telling you that x is a discrete random variable and it takes the value 0, 1 and 2. 0, 1 and 2. Okay, the probabilities are given to you. Probability for x equal to 0 is 0.25 and the probability for x equal to 1 is 0.5. Right. Question में पूछा है, sir, what should be the value of e of x minus e of x square? Right. Mean value minus mean square value. Mean value minus mean square value. Hi guys, good afternoon everyone. And if you are one of those who have appeared in the today's examination, let me know how was your paper. How did you feel the level? How did you feel the level was? So guys, very simple. Okay, the summation of all probability, the summation of PMF always equal to 1. So on the basis of this, see, the probability, the random variable can take the value 0, 1, 2. Okay, sorry, ये data. Sorry. इसको rotate हटाते हैं. Probability x equal to 1 is 0.5, is 0.5. Correct. Now, there is one data that is missing. What is the probability x equal to 2? So, sir, what is the probability that x will be 2? The sum of the probability should be 1. So, that is 1 minus the given probability. 2 of them are given. Third is missing. So, it has to be 0.25 only. It has to be 0.25. The probability x equal to 2 is 0.25. Is that clear, everybody? Okay. Now, what is the E of x then? E of x is summation of x into PMF. Right. So 0 multiplied by 0.25. Then I have the 1 is multiplied by, okay, where is that value? 0.5. And then I have the next value 2, which is multiplied by 0.25. Right. So next net answer is 0.5 plus 0.5, 1. E of x is 1. The mean value is 1. Okay, the mean value is 1. Now let's talk about the mean square value. So what is going to be the mean square value? Right. 0 square into 0.25, 1 square into 0.5, 2 square into 0.25. So this part is 0, then 0.5 and 4 into 0.25, 1 plus 0.5, 1.5. So what's going to be your answer, dear? Mean value 1, mean square value 1.5. minus 0.5, and I think it's a NAT question. Yeah, it's a NAT question. Okay, it's a NAT question. Right, everybody? Minus 0.5, please check it up. Minus 0.5, please check it as. Yes, sir. The Sahiti says already the answer minus 0.5. Chalo. All right, badhiya. So let's move ahead to the next agla question, dear. Okay, so now a question on the power series, but very simple. The question on power series. So we have 5, 6 maths question, then control and digital logic and sequence we shall discuss. Okay, so next is you are given a complex function f of z is 1 upon 1 minus z. Okay, when expanded as a power series. So this is going to be expanded as a power series. Okay, and that is around z equal to 2. The expansion point is z equal to 2. Okay. Okay, would result in what? Would result in f of z is equal to summation of the ak z minus 2 raised to the power k for k equal to all values, that is 0 to infinity, right, with the ROC given to you, with the region of convergence modulus of z minus 2 is less than 1. Okay, question is what should be the coefficient ak, and there are the 4 options also given, that is the half raised to the power k. Option B is the minus 1 raised to the power k, minus 1 power k plus 1, and the next option minus half ki power k plus 1. Tell me, dear, if you have attempted this question. It's a fundamental question. It's a fundamental question. Tell me if you have attempted this question and let me know what your answer can be. Okay, the power series is in the is about the point z equal to 2, that is in form of z minus 2 power, and I have been given the function which is 1 upon 1 minus z, or I can write this as 1 upon z minus 2 plus 2. Let's make it as a function of z plus 2, and clearly that this becomes 1 minus 2. So minus 1 minus of z minus 2. So now I have the very simple analysis of the function. Minus of, take the numerator above and minus is common. So 1 plus of z minus 2 ka whole inverse, and that's like 1 plus x whole inverse. You can have a 1 plus x whole inverse directly. 1 minus x plus x square, okay, minus of x cube plus of x ki power 4, etc, etc, etc. That is what is the function you have. Now, very simple analysis here is, acha, now this also looks like a geometric series with infinite term, and that is why the ROC is given. The modulus of r less than 1, the modulus of z minus 2 should be less than 1, and that is satisfied. The ROC is given. So yes, we can use this, we can expand this. So with the given condition, modulus of z minus 2 less than 1, my final answer will be minus 1 plus of z minus 2 minus of z minus 2 ka whole square plus of z minus 2 ki power 3 and etc. Now we are able to see that the coefficient is positive. Okay, z minus 2 ki power 1, z minus 2 ki power 3, right? For odd k, that means for odd powers it is the positive, and it is equal to minus 1 for even k. Even के लिए minus है. That means my AK could be in the form of minus 1 की power k plus 1, so that whenever k is even plus 1 will be odd, minus 1 power odd is odd. Right? Similarly, if k is odd plus 1 is even, and minus 1 की power even will be plus 1. Okay, so the correct answer is minus 1 की power k plus 1, and the correct answer is C according to me. Everybody. Samir, please recheck. It's not D, it's correct answer. That is C. That should be the C. This is an MCQ question from the engineering mathematics. चले अगले question की तरफ. All right, great. Let us move ahead to the next question. Let me cover up first maths question, then we'll go to control and digital all together. Then we shall go to the control and digital all together. Next, again a simple question, dear, from mathematics coming up on my way. Here it is, the next question for you, dear, and that is rank of the matrix A. There is a matrix A given and the rank is 1. Okay, the question is find the ratio alpha by beta. Find the ratio alpha by beta. What is the matrix given to you? 1, 4, minus 3 and alpha, beta and the 6. The rank of this matrix is equal to 1. What should be alpha by beta? So if you see, all right, Shashikant says the solution is correct. Fantastic, Shashikant. All right, so now rank is equal to 1. The rank of the matrix is 1. So that simply means all 2 cross 2 minors, the evaluation of all 2 cross 2 minors should be the 0, na? Right. So that means one of the minor is here in front of you, which is evaluated to alpha minus 12. Alpha plus 12 is 0. So sir, alpha ka to value aa gaya. Similarly, I can take this 2 cross 2 minor as the first row and the third row. So 1, 4, beta 6. This should also be 0. So 6 minus 4 beta is 0. So sir, the value of beta is equal to the kitna hoga? 6 by 4, that is 3 by 2. Now what is alpha by beta? Minus 12 divided by 3 by 2, so 24 by 3. Minus 8 should be my answer. And it was again a NAT type question, right? Let me just rectify. Yeah, it's a NAT type question as far as the data I have got. Right, so Sahiti says the same answer, Rityaksha says the correct answer. Great, guys. So it's a fundamental question. Okay, or you can also check the rank by dependency method. Rank is equal to 1. Rank is equal to 1, तो only one independent row. So right. So alternative क्या हो सकता है? Right. Alternative is only one independent row. वहां से भी आप लॉजिक अप्लाई कर सकते हैं. The matrix should have only one independent row, right? ठीक है. So if 1 into second row should be dependent on first. So how it is dependent? 1 into minus 3. So similarly 4 into minus 3 should come here. The alpha is minus 12. Like that also you can try. चलो चलते हैं अगला क्वेश्चन की तरफ. Any one method, both are fundamentally correct. Okay, next question. Let me try to wrap up the whatever maths question I am able to find. It's a mixture. Where is the other question? Acha, chalo. Here I have another question of the maths. Simple one. Choose the solution set. Okay. Choose the solution set S. Okay. For the linear system of equation. What are the equations given? X minus 2y plus z is equal to 0. and x minus z is equal to 0. Underdetermined system. 3 variables and only 2 equations, so it is the underdetermined system, underdetermined type of system. Okay, and the option is S is equal to alpha 111 plus beta 101, right, for all alpha beta belonging to real numbers. Okay, sir, option number B. इसका solution ना बहुत simple है. Just let me write down the options. Allow me to write down the options. Rest the solution is simple. So S is alpha 111 such that alpha belongs to real. Option number C लिख देते हैं dear. Option number C, S is equal to the set alpha 111 plus beta 212, I think लिखा हुआ है, beta 212 such that alpha beta belonging to real. And option number D, इस क्वेश्चन में जो भी टाइम खराब हो रहा है, only to write the option, rest it is very simple. Alpha 101 such that alpha belonging to real. Now it has a very simple solution. And what is the solution? Anybody please tell me if you have the solution. So sir, x minus z to 0 hai, so z is equal to x. And if z is equal to x, so I have x minus 2y plus z, but z to x hai, that is equal to 0. So 2x minus 2y equal to 0. So that simply means y is also equal to x. Y is also equal to x, right? So guys, let x be any number alpha, then what is the solution? Then what is the solution? X, y, z, right? Y is also x, z is also x, then it is alpha, 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 where alpha can take any real value, na? Of course there will be, okay, of course there will be infinite number of solution. Of course there will be infinite number of solution because it's an underdetermined system, na? ठीक है. So guys, answer is alpha, alpha, alpha. That is the answer is B. How simple it is. मैंने बोला था ना, इस क्वेश्चन में मेरे को केवल ऑप्शन लिखने में टाइम लगेगा. Rest it is a one-liner answer. Rest it is a one-liner answer. ठीक है. चलो, let me search. I think probably one or two questions from maths we have, and then we will write down the answer. Okay. Where is, yeah, so we have another question from mathematics, dear. We have the another question from mathematics. What is that question? Okay, you are given a real valued function, that is the g of x, which is maximum of, right, maximum of x minus 2 whole square comma minus 2x plus 7 comma minus 2x plus 7, where x can go from minus infinity, matlab x can take all values minus infinity to infinity. Okay, what is the minimum value attained by gx? Dear, what is the minimum value of gx? Okay, again NAT question, again it's a NAT question. चलिए देख लेते हैं इसको. So what should be the answer for this, dear? Now x minus 2, we know both the plots roughly, है ना, एकदम quickly and roughly ले लेते हैं. अच्छा, where they are going to intersect? Where they are going to intersect? So when x minus 2 whole square is going to be minus of 2x plus 7, so I have x square plus 4 minus 4x is minus 2x plus 7. So I am getting x square, इधर ले आएंगे तो minus 2x and 4 minus 7 minus 3 equal to 0. So I should be having the x minus 3 and x plus 1 equal to 0. So x is equal to minus 1 and plus 3. Please check the intersection point 1. X is equal to minus 1 and plus 3. And I have x minus 2 ka square, a parabola starting 2 units down. Right, 2 units down. Okay, so something like this. Let me draw both actually. दोनों ही बना लेते हैं. So I have the parabola passing through this point, which is y equal to minus 2, and then I have the straight line minus 2x plus 7, and they are intersecting at minus 1 and at the plus 3 and at the plus 3. Okay, y intercept इसका लेंगे mx plus c, तो y intercept is 7, y intercept is 7. Okay, and they shall be intersecting at x equal to 3, तो ये point हो जाएगा. चलो, something like this. ठीक है. something like this dear. ठीक है? So this is the line minus of 2x plus 7, a straight line with negative slope, and this is your parabolic curve given x minus 2 whole square. Now what is the minimum value attained? Now the function gx is the maximum of these two. What is the function? I've drawn both of them. This is not the final function. Okay, this is the intersection point on the right hand side. So say this should be the x equal to 3, right? And x equal to 3, the value of the function is 1. Now this is the function. Actually, this is the function. थोड़ा highlight कर देते हैं. Let me take it something like this. So the function should be maximum of 2, right? So up to this portion, up to x equal to 3, I will take the straight line because that is higher in value. I need the maxima, right? And then beyond that, straight line value becomes less and the parabolic value is dominating. So we'll take the parabolic curve. This is the actual curve, right? This is what is the g of x. So what is the minimum value of the function? It attains at x equal to 3 and the value being 1. The value being 1. Check कर लीजिए एक बार. Minimum value बोला है, maximum नहीं बोला है. Please check out this value. Please check out this value. The minimum value attained. Rityaksha and Kapila, Kaipa Sahiti. Check out. Okay. They are intersecting at x equal to 3. Before x equal to 3, straight line is dominating, and after x equal to 3, parabolic dominating. And anyways, minimum value is at the intersection point. Intersection point x equal to 3 आया है. Put any one, 3 minus 1 whole square, या minus 2 into 3 plus 1, answer should be the 1. And this is what is the minimum value, right? Answer is the minimum value attained by the function is 1. Ask me if you have any doubts. ठीक है? चलो yeah. And these questions are, you know, these is even last weekend we saw a similar question. We had two functions and their maxima or minima is discussed. Last year also, if you look GATE 2022, there was a question of this kind. Okay. So it's all about, you know, understanding and sketching of the very, very simple curves. ठीक है जी? आगे चलते हैं. So any confusion, let me know. It's not 2 or 2.25. It's coming out to be 1. The minimum value is turning out to be 1. So what is the next question? What is the next question we have? Yeah, chalo. So we have, I think, probably one more question from maths is here. Okay, so I think we have got 6-7 maths question by this time. Where is that question gone? Yeah. Question is a regular question expand on limit x tending to 0, limit x is tending to 0, x into sine of 1 by x, x into sine of 1 by x. Option number A does not exist. Option number A does not exist, right? Option number B, it is 1. Option number C, it is 0. Option number D, it is infinity. X tending to 0, sine of 1 by x. X is tending to 0, sine of 1 by x. Chalo. Or if you have any confusion by chance, na, you can write this as limit t tending to infinity. Limit t tending to infinity. Let 1 by x equal to t. So it will become sine t. Divided by x is 1 by t, so sine t by t, but t is tending to infinity. Tell me the answer, dear. You can say directly also, or you can देखो directly भी बोलोगे तो this is like if I take the concept of t tending to infinity, we know sine infinity. We can't exactly determine sine infinity, but it doesn't mean that answer will be does not exist. I'll tell you what, we exactly can't determine sine infinity because nobody knows what infinity value is. But we at least know that for all values of theta, sine theta is finite. It lies between -1 to +1. And when you divide by infinity, finite upon infinite always tends to 0. It always tends to 0. It always tends to 0. Now, why it is tending to 1? 1 to tab aata when it is x tending to, when it is t tending to 0, sine t by t, baba, no, that is a mistake. Okay, it's not 1, dear. What is the blunder? यहाँ से भी direct देख सकते हो ना, if you don't want to convert to t, right? So it is 0 into sine infinity, 1 upon 0, and sine infinity is finite. 0 into any finite value would always be 0. 0 into any finite value, be that positive finite, be that negative finite. X tending to 0 plus 0 minus p करने का need नहीं है, and answer is going to be C. Answer is going to be C. Yeah, Ravi Teja correct. Ravi Teja correct. Guys, it's not 1. I think you have misread the question. X tending to 0 है ना? मैं check करूँ एक बार. Yes, guys, x tending to 0, x sine 1 by x. Guys, you have misread the question, I think. Question को गलत है. Answer 1 तब होता when it is x tending to infinity. Then you will get t tending to 0, sine t by t. Then it is equal to 1. All clear now? Tell me in the comment box at least. Okay. अगर mistake को correct कर लिया तब भी एकदम कोई दिक्कत नहीं है, है ना? चलो. So let us move ahead to the next question. Now I shall be taking some question of control system. Let me search out where are the control system questions, dear. Control systems पे चल रहे हैं. Okay, chalo. Yes, dear. So now let us take some control system questions here. Okay. Nah, then also not correct, Niranjan Baba. X is tending to 0, so 1 upon x is infinity. 1 upon x is infinity. Sin infinity upon infinity. कैसे 1 होगा? You are thinking about sin 0 by 0, dear. Okay, Niranjan. चलो. Sin infinity by infinity 0 थोड़ी ना होगा. थोड़ी 1 नहीं होगा ना. It will be 0 only. चलो, dear. So control system questions, and now I have a question from the control system. Okay. What is the number of zeros of, बहुत ही simple यार, cubic दे दिया. Number of zeros of the function s cube plus 2s square plus 5s plus 80 in the RHP. Your cubic equation, not even fourth or fifth order. So s cube and s square से start करेंगे. Okay, and then s cube 1 and 5, s square 2 and 80. So I have 10 minus, sorry, ये था 80 ना, 10 minus 80, minus 70 by 2, minus 35, last element 0, minus 35 into 80 divided by minus 35, 80. So dear, कितना sign changes आया? I am able to feel that there are 2 sign changes. Answer is 2. Number of RHP roots is equal to number of sign changes in the first column. That's it. Okay. Okay. Yes, Sahiti. Correct. तो आंसर तो previous case का 0 ही होगा. So I think still some of you are confused here. Okay, no problem, Rityaksha, no problem. So this is equal to 2. This is equal to 2. Okay, there are 2 sign changes. Chalo, let's move ahead to the next question from the control system. Where is the next question? So I have lots of questions mixed with me. अच्छा, maths के 1 or 2 questions more I have found. No problem, वो भी discuss कर लेंगे. चलो, next question I have found here. Please have a look into this next question, dear. Just a moment. Okay. System has the transfer function. Okay. Ys upon xs. A system has the transfer function ys upon xs is equal to the s minus pi is divided by s plus pi. Okay. And let ut be the unit step function that you all know. Okay. Find the input xt that results in the steady state output. So steady state output is given to you. Sinusoidal response pe. The steady state output is given to you, and that steady state output is given by sine of pi t. That steady state output is given by sine of pi t, right? For this output, select the corresponding input. Select the corresponding input. Okay, allow me to write down the options. Option number A. Okay. Option number B. चलो वो सभी में common है. I'm not repeating that. सिर्फ इतना लिख लेते हैं. Then I have the option number B. Okay, that is sine of pi t plus pi by 4. Then I have been given option number C, sine of pi t minus pi by 2, and then I have been given sine of pi t only. Tell me, dear. Tell me. Now input has to be determined, output is given to you. So if we take the frequency domain, frequency response of the system, so that will become j omega minus pi upon j omega plus pi, and okay, we know that for sinusoidal input, the input frequency and output frequency is the similar. Okay, is similar. So if the output frequency is pi, if the output frequency is pi, input frequency is also pi. So if I take omega equal to the pi na, right, what is the frequency response of the system? Then it is known as j pi minus pi divided by j pi plus pi. Pi will get cancelled, It is j minus 1 divided by j plus 1. So when I want to talk about, or it is minus 1 plus j divided by 1 plus j. So dear, when you want to write it into the Euler form, when you want to write it into the Euler form, m e power j phi, what is the magnitude? Under root of 1 square plus 1 square, under root of 1 square plus 1 square, that will get cancelled. The magnitude is 1, fixed. Okay, it's an all pass type of system, magnitude is fixed, e power j phi. What is going to be phi? Magnitude to 1 aa gaya. Sir, what is going to be phi? So you can see that, na, tan inverse 1 upon minus 1, tan inverse y upon minus x, minus tan inverse 1 upon 1. Okay, so this is tan inverse y upon minus x, 180 degree minus tan inverse y by x. So 180 minus 45, the face is 90 degree. So r e raised to the power j pi by 2 in terms of radian. So the frequency response will introduce a phase plus pi by 2, plus pi by 2, है ना, plus pi by 2 in the output. Now, output is only sin omega t, so input should be sin omega t minus pi by 2. देखो, magnitudes are same. Why magnitude are same? Because the magnitude of the system is 1. That is why it doesn't alter the magnitude, but sin pi t minus pi by 2 plus pi by 2 will give the 0. So the correct answer has to be C. Correct answer has to be Z. Okay, the correct answer has to be C. Clear? Got this, everybody? Got this, everybody? ठीक है, हम ऐसा बोल सकते हैं ना, right? Input phase plus of pi by 2 should be the output phase. ठीक है? So that is why this should be having a term minus pi by 2. Clear, everybody? So the answer is C. The answer is equal to the C. चलिए अगला question ले लेते हैं, again control systems. So what is the next question I have in the bank? This is done. What is the next question, dear? Just a second. Okay, a fundamental question from Nyquist plot. Number of times the Nyquist plot, the number of time Nyquist plot of, यहाँ लिख देते हैं, of GSHS, the Nyquist plot of GSHS equal to S minus 1, S minus 2. S minus 1, S minus 2 divided by twice of S plus 1, twice of S plus 1, S plus 2 encircles the origin. The number of time Nyquist plot of GSHS equal to this encircles the origin. How many times it encircles? Origin means 0, 0 only. यहाँ पे minus 1, 0 stability वाले criteria की बात तो नहीं की है, right? So dear, okay, they haven't asked about direction. Okay, so we can just talk about the number of encirclement, and the direction of encirclement definitely will depend on the Nyquist contour. Okay, definitely depends on the Nyquist contour. दोनों केस में बता दूं, आंसर तो एक ही आने वाला है. So Nyquist contour is not mentioned to me. Okay, suppose if it is a clockwise Nyquist contour, then the number of encirclement will be given by P plus minus Z plus. Acha, what is the value of P plus? How many poles in the RHP? There are no poles in the RHP. Minus and minus 2 are the poles. And how many zeros of GSHS? Because I want the encirclement of origin, I should look the zeros of GSHS, not 1 plus GSHS. So zeros of GSHS kitna ho jayega? S equal to 1 and 2, and both are in the RHP. Right? Then in that case, N is equal to minus 2. That is 2 clockwise. Matlab, if the Nyquist contour is clockwise, there will be 2 clockwise encirclement, tracing the same direction as contour. If it is anti-clockwise, then we can use the Z plus minus P plus, or you can change the sign of N. One and the way, it's about your outlook about Nyquist. So N equal to 2, right? That is 2 anti-clockwise. So in any ways, how many times it encircles the origin? The answer is going to be 2. The answer is going to be the 2. Okay, so they haven't mentioned the direction. So of course, the direction of encirclement will be same as what is the Nyquist contour, which is not mentioned. So any of the case, number of encirclement to 2 ही होने वाला है. Plus or minus is just a reference point to distinguish the direction. Clear, everybody? So that is again a very simple question, very fundamental question. Very fundamental question. Next question, control. I think I had one more question. Here it is. Chalo. Yes, dear. This is the next question coming up here. Question is very simple. The face margin, okay, the face margin GS is given to you twice of 1 minus S is divided by the 1 plus S ka whole square is dash. Is dash. Dash in degrees. Nat. It's a NAT question, na? Tell me how much, guys? Tell me how much? Tell me, dear. So Gj omega is twice of 1 minus j omega upon 1 plus j omega ka whole square. So if I want to talk about mod Gj omega, so that is twice of under root 1 plus omega square upon 1 plus omega square, under root and square cancel, the 1 plus omega square. Or I can say the magnitude is 2 divided by under root of 1 plus omega square, right? So if I want to find the gain crossover frequency, okay. Acha, diagram. So maybe that diagram question I haven't got yet, Sahiti. If I get that, I'll discuss that also. Frequency and magnitude plot. Okay, so maybe मतलब board पे होगा question. So that is 2 divided by the under root of 1 plus omega square should be 1. At the gain crossover frequency, magnitude is 1. Magnitude is 1. तो इसको solve करेंगे तो I should have 1 plus omega square का under root equal to 2. तो 1 plus omega square is 4. Omega is equal to omega g is root 3 radian per second. So gain crossover frequency आ गया. Okay. Now omega g is root 3. So what is the angle gj omega now? Sir, angle gj omega is tan inverse minus omega. So that can be written as the minus tan inverse omega. And then I have 1 plus j omega square. So 2 times tan inverse omega. Right. So what is the angle actually? So angle gj omega is nothing but minus 3 tan inverse omega. Okay. So what is the angle gj omega g at the gain crossover frequency, which is root 3, tan inverse root 360 hota hai, so minus 180 degrees the phase. That is why when you take the phase margin is 180 degree plus the phase at omega g, and that is equal to 0 degree. And whenever you get 0 degree, yes, Raspian says the correct answer, Deepshika Raj says the correct answer, Manish says the correct answer. Yes, it's 0 degree. And whenever you get 0 degree, you can just, psychologically verify also, right? Phase margin kitna aaya? 0 degree. Indicating what? Phase margin 0 is for a marginally stable system. Acha. What is the characteristic equation, dear? If you just want to confirm once again, so characteristic equation 1 plus gs equal to 0, 2 1 minus s upon the 1 plus s whole square equal to 0. So s square plus 2s plus 1 plus 2 minus 2s is 0. So 2s got cancelled. S square plus 3 equal to 0. S equal to plus minus j root 3. Pure imaginary roots. So confirms marginally stable system. Pure imaginary roots confirms the marginally stable system. Clear, everybody? Pure imaginary, so it confirmed the answer. Okay, it confirmed our answer. Done hai? Okay, so we can be sure at least marginally stable को identify कर लिया है. Simple one है. Okay. I think these are 3 or 4 questions of control system that I have got. Let me check. Chalo, moving ahead to the next. Itna hi hai abhi. Control, digital. So few questions of digital. Again on a easy level only. Okay. You have to just match the following. Okay. 1 x XOR x. Basic, very fundamental XOR property. X XOR x bar. Option number 3. X XOR 0, option number 4, X XOR 1, right? And if I talk about P, it is 1. If I talk about Q, that is given to you as 0. R is the next statement that is given to you as X bar, and S is the next statement that is given to you as X. Quickly match kar lijiye, tell me. Right. All right, Raspia, great to know that. X XOR X, same input in XOR output will be 0. X XOR X bar, X and X bar are different. So XOR will give the correct high output. X XOR 0, X into 0 bar will be X plus X bar into 0. X into 1 bar will be 0 plus X bar into 1. So it is X bar. Simple. Simple. Okay, so we have 1 with Q, 2 with P, and similarly the 3 with S and 4 with the R. That is the matching. Clear everybody? That is the matching. Chalo, done. Yeah, same thing, Ravi Teja, you are telling. Correct answer, guys. Next question coming up from digital. Just a moment, let me search that. Okay, next one. Again, a simpler one here. Again, a simpler one here. Kya given hai? Okay. Just simplify. A very fundamental K-map question. Simplify F, that is WXYZ. WXYZ is equal to summation of the minterms given to me 4, 5, 10, 11. 4, 5, 10, 11, 12, 13, 14, 15. 12, 13, 14, 15. Okay. Okay, and there are the 4 options given to you. X, Y bar plus WY. Option number B hai X, W into X plus W bar X, Y bar plus W X bar Y. Okay. Next is WX plus WY plus XY bar, and option number D is X bar Y plus W bar Y bar. Clear hai? बिल्कुल सही है सर. ठीक है, चलो. So let's solve this. It's a very fundamental K-map question. Okay, so what are the minterms given to me? The minterms that are given to me is 4, 5, then 10, 11, 12, 13, 14, 15. This is the entire row that will come up. And if I want to just start with the pairing, अब देखो, grouping होगा actually. This is a group of 4 because these two can only be grouped with the next two ones. So this is a group of 4. And here, now, even if you take this row, will it be useful for you? Because these two minterms, na, they can make a quad. Why to take it as pair? And if you take this quad, na, no need to take any unnecessary term. So only 2 quads are there. Okay, only 2 quads are there. And we all know that this is WXYZ. So I can call it as WXY. This portion is Z. So this is the quad lying in X as well as outside Y. So XY bar plus this next quad, that is W and Y fitting. So that is WY. Okay, XY bar plus WY. Option number A. XY bar plus WY. Yes, Rityaksha and Ravi Teja, correct answer. That is the correct answer. Next question ले लेते हैं हम लोग digital से. Okay. All right, dear. A and B are 1. Okay. Then delays of AND or NOT gates are given to you. And what are the delays? 10, 10 and 5. 10 nanoseconds, 10 nanoseconds, 5 nanoseconds respectively. है ना? Respectively map कर लेना. Okay, there is no line delay, matlab there is no delay of the wires to be considered. Okay, C equal to 1 when the circuit is turned on. When the circuit is turned on. Okay, what is the frequency of, ये decent question है थोड़ा. What is the frequency of steady state oscillations? Always I told you questions based on logic gates and their delays are very important. The frequency of steady state oscillations, output Y, is dash. Okay, dash. Unit शायद यहाँ पे missing है, तो unit हम खुद ही बना लेंगे, no issue. And what is the circuit given to me? Sir, what is the circuit given to me? Okay, dear. This is the C. Given that C equal to 1 when the circuit is turned on. Clear hai? And this is the output Y. We need to find the steady state frequency of oscillation at the output Y. Ganesh says answer is 20 megahertz. Okay, NAT question hai. मैं यहाँ पे assume कर लेता हूँ megahertz में होगा. Okay, you can correct me, that is missing here. Okay, the unit is missing, but megahertz में आप लोग बोल रहे हैं तो megahertz में होगा. Unit कुछ भी हो सकता है. But you have to just fill it correctly. So देखो, C equal to 1 at the start of the cycle, and if C is equal to 1, this is eventually 0. A and B are fixed at 1. A and B 1 पे fix है तो 1 का complement 0, right? A is fixed at 1. So if you see 1 reaches here, right? A complement of B is equal to 0. Okay, complement of B is equal to 0, and that is always fixed. So this is the delay counted in the first state, but not in the steady state. ठीक है? तो steady state में इसका delay negligible होगा. We don't have to count that. So actually, if you see, C is just equal to Y. C is just equal to Y. इसको हटा दे तो this is like Y bar. Okay, and Y bar plus 0 will be Y bar. So what is the next state of the device? Let's say the next state of the device, that is Y bar into 1, and that is just Y bar. So at every particular cycle, it is just going to toggle. But how much is one cycle? So let's say, sir, C was initially 1, na? C was initially 1. After 5 nanoseconds, ये कितना है? 5. After 5 nanosecond, it toggles. Okay. Then don't count this because this is not going to be counted in the steady state. The delay of OR gate is also 10, and gate का भी 10 है. So after 10 more nanoseconds, you are going to get the response here. That becomes 15, and 15 plus 10, 25. So one delay is, okay, one delay. The overall TPD of the circuit is 25 nanoseconds. Okay, now if the initially C was equal to kitna 1, this is 0, 0, 0. Initially Y was 0. Initially Y was 0. Okay, 25 nanoseconds ke baad it becomes 1. Another 25 nanoseconds. So if I say this is T equal to 0, so this will be T equal to 25. This will be T equal to 50. Another 25 nanoseconds, it is again going to become, so ये हो जाएगा 75. It is again going to toggle and etc. So what is the time period? And accordingly we can get the frequency. What is the time period? What is the time period? ठीक है? What is the time period? So the time period of the waveform obtained is clearly 50 nanoseconds. The timing are in 50. So your answer should be 1 upon 50 into 10 power minus 9. और अगर megahertz में पूछा है तो आ गया ना 10 power 3 divided by the 50, and then rest is 10 power 6. So 1000 by 50. Correct. So that is equal to the 20. So 20 megahertz. 20 megahertz. Raspia says that it was MCQ question. Maybe. मतलब this is what data I have got. देखो कोई फर्क नहीं पड़ता MCQ, NAT. It's a very simple question. Option दे के भी यहाँ पे ज़्यादा कुछ नहीं होने वाला है. Without options we are able to do it. Clear everybody? Clear? चलो next देख लेते हैं. I have to search through. बहुत सारे question है यहाँ पे. Let me just scan the questions again. Okay. चलो ठीक है. Tell me if you have any doubt. The answer is 20 megahertz. No problem. 2-3 minutes. हाँ. 2-3 minutes. Okay. So yes, dear. Next. Okay. The table shows. Okay. There is a table given. उस table को directly लिखते हैं. वो क्या show कर रहा है? यहीं पे show कर देते हैं. So there is a QT, and there is the next state QT plus 1, and then there is the input given. And then there is the input given. Clear everybody? And then there is the input given. Ready? 0, 0, 0, 1, 1, 0, 1, 1, and input is given to you 0, 1, 1, 0. Okay. Question क्या पूछा है? Identify the flip-flop, dear. Identify the flip-flop. Option number है D. Option number B JK. Option number C SR. Option number D T. भाई पहली बात तो एक ही इनपुट है. JK SR तो हो ही नहीं सकता. Tell me यार, how simple it could be. Flip-flop questions which are usually good, but now this time the good question is only the logic gate delay question. That is also good. It is not difficult. Good और difficult में एक boundary होती है, वो समझना जरूरी है. Okay. So now dear, what is the answer? Whenever the input is equal to 1, whenever the input is at 1, you say the next state is toggle 0 ka 1, 1 ka 0. So whenever input is equal to 1, QT plus 1 is equal to the toggle. Right? But if the input is equal to 0, what is the QT plus 1? Okay, 0 ka 0, 1 ka 1. So QT plus 1 equal to QT. So which behavior is this? This is the behavior of the T flip-flop. Right? So भाई इससे ज्यादा सिंपल तो फ्लिप फ्लॉप से मतलब मुझे नहीं लगता पूछ सकते हैं. Right, cutoff will be definitely high. Very simple. Sir, what do you say till now? I have seen very simple questions.
Yeah, it's very simple. Sir.
Very simple.
From my side also.
From my side. Yeah, we will come up with iron core response as well. जो iron core questions है उसका भी analysis अभी बहुत जल्दी ले आएंगे. But as far as sir control system, digital logic, maths, extreme simple. मतलब very simple actually.
Okay. Analog is bit tricky, but network is very simple, sir.
Network is simple. Analog is tricky. And I think iron में analog थोड़ा decent आता ही है. Okay. Every time that I have got. चलो. So guys, finally just last में एक दो question maths के और randomly दिख गए तो discuss कर लेते हैं. So that I think all maths question will be discussed. So one more question based on complex function. One was the power series that we have discussed. J into 1 minus z divided by 1 plus z is the function given. Okay, z is a complex number. J denotes under root minus 1. सभी को पता है. Okay, question is f inverse z. Question is f inverse z maps the real axis to what? Option number A, unit circle. Okay, with center not at origin ये mentioned है. Unit circle with the center not at origin. Tell me क्या करेगा? Option number B says it maps the real axis to real axis. Option number C क्या बोल रहा है? It maps it to the imaginary axis. And option number D, unit circle with center at origin. Tell me guys, what have you marked? Okay, Rityaksha says circle, Sahiti says imaginary axis. What is the correct answer? Simple sa question hai. So if I want to discuss the inverse of this function first of all, guys, what is the f inverse of z? That is nothing. 1 by j ka inverse will become minus j, and then I have 1 plus z divided by 1 minus z. But I want the mapping of what points? It maps the real axis to what points? Okay, so आपको केवल क्या करना है? Let z is equal to x, which is purely real. If I take all real values, then I am getting f inverse z is equal to minus j 1 plus x divided by 1 minus x. Clear? Tell me now. This 1 plus x upon 1 minus x, this is again real. So minus j of real, it is something like minus jy. So it maps where? It maps it to the imaginary axis. ठीक है, मतलब 8-9 question. ठीक है, done. I think I have one last question only.
Okay.
ठीक है, I think so. Tell me, dear.
But then I will get sometimes.
Okay.
If you come again, then I'll get sometimes.
Okay, ठीक है.
So better.
चलिए ठीक है, कर लेते हैं. Yes, sir, it is inverse of fz, not fz inverse. हाँ, fz inverse लिया भी नहीं है, dear. I have not taken fz inverse. I have taken f inverse z only. Fz inverse is a different parameter. Tell me. So it's purely mapping it into the imaginary axis. It's mapping it into the imaginary axis. See, चलो, ठीक है. चलो. So guys, I think I have one more maths question. आके discuss करते हैं. But I'll just give you the hint. Where is that question? दिखा तो था मुझे. I'll just give you the hint of the topic. Very fundamental differential equation question is there. Okay, so that we can discuss later. I think sir wants to continue. So sir, what is that you have brought now? Network,
analog and machines.
Network, analog, machines. Okay, so very important points are given.
Almost 10 questions,
Okay.
and let's try to solve these 10 questions, guys. And let's start these questions. Yes, sir. Yes, I have the pen. Okay. I'll get some time, sir. That's fine.
Yeah, sure.
Okay, sir. Okay, guys. So let's first start with the network question, and the question is given to you. And let me draw the diagram. And
क्या बोल रहे हैं? At x equal to 0, y is 1, na? But the answer is minus jy. Look into it, Rashmi. The answer is actually minus jy. That is purely imaginary. It is purely imaginary. It will only be undefined for one value, that is x equal to 1. वो skip करना पड़ेगा. Rest all is satisfied. चलो, sir, continue.
okay, guys. So let's start with the question, and the first question is about the balance bridge. Okay. So the question is like this. Let me redraw the diagram. So the diagram is like this. We have an ammeter, and the ammeter has the internal resistance of 100 kilo ohm, okay, and there are some 3 branches connected like this in delta form, okay, and the value of the resistance is will be 10 milliohm, okay. This is again 10 milliohm and this is again 10 milliohm, okay, and there is one branch connected here, and this is a voltage source. I think this voltage source is 1 volt, okay. These resistances are not provided to you, and this current is given as 3 milliampere. This current is given as 3 milliampere, and on this side again we have 2 resistances. So please confirm this question, whether this question is correct or not, okay. So this is the question. When the bridge given below is balanced, the current through the resistor RA, and this is RA resistance, okay. This resistance is RA. We need to calculate the current through this resistance. So tell me guys, is it correct or not? I think this was the question which is provided to me. So let's try to solve this question. I think this was the question. Tell me everyone, is it correct? Is the question correct? So we need to calculate this current. How to calculate this current? It is given that the bridge is balanced, okay. The bridge is balanced. It means there is the voltage at this point and this point is same. The current through the the galvanometer is not showing any deflection. It means the current through the ammeter is 0. Okay, if the current is 0, it means this voltage and this voltage is same, and this current is 0 ampere. Now look at this. We have this 3 milliampere. So obviously the current will go like this. So there are 2 ways of solving this question. One way is via this path the resistance is 20 milliohm, and via this path the resistance is 10 milliohm. So what you can do is you can divide this current and you can calculate this current, okay. So this is easy peasy. Okay, let's try to solve this. Let's try to calculate this current. So if you apply the current division rule, that is 3 milliampere into this branch, because there are 2 parallel branches. There is no connection with this, no, because the current entering is 0. There is no current in this branch. So whatever current going in this side, the same current will flow like this, okay. So you can say that this 10 milliohm and this 10 milliohm, which is 20 milliohm in parallel with 10 milliohm. So what you can do is you can apply the current division rule. So 3 milliampere into 10 milliohm divided by the total resistance. Total is 20 plus 10, that is 30 milliohm, okay. 30 milliohm. Now you can cancel this milli to milli, and this is cancelled, this 1. So answer is 1 milliampere, okay. Answer is 1 milliampere. Is it clear guys? Tell me, answer is 1 milliampere. There is one more way to solve this question, and that way is again using star delta conversion. Let me tell you that method also, because with each question my confidence is going down, okay. Ruspian, so don't worry Ruspian, I mean these questions are very easy. Let me give you one more idea for this question. What you can do is you can convert this delta into star, okay. Let's convert this delta into star. If you can convert this delta into star, then the value will be, what is this value guys? This will be 10 milliohm divided by 3, okay. 10 milliohm divided by 3. So what you can do is, we know that this current is 3 milliampere. Okay, let's call this point A, we call it B, we call it C, okay. So this point is A, this point is B, and this point is C. Now what you can do is, we know that this current is 3 milliampere, okay. And this resistance is again 10 by 3 milliohm, okay. This is again 10 by 3 milliohm, okay. Now what you can do is, you can calculate this voltage. So this voltage came out to be 3 milliohm, 3 milliampere into this this resistance. You will get this voltage, okay. You will get this voltage, and similarly you can see that this current will be 0. This current will be 0. You can say that this current will be 0. So the entire current will flow through this. Entire current will flow through this, okay. So the 3 milliampere will enter here and it will go from this side. So we know that in this branch we have 3 milliampere, but we want the current in this branch, okay. So we know that this current is also 3 milliampere. Now we want this branch current. Now how to calculate this current? Tell me guys. Is there any other way? Okay, I think this is not the correct way. Why? Because many students, what they will do, they will say that this is the phase voltage and we can multiply with √3 to calculate the line voltage. That method is not correct because this is DC supply. So the only method is this method. Okay, so current division method is the correct method, because I was thinking in that approach also, and some student might also think about that, because you can convert this delta into star, and then you can say that this 3 ampere, you can calculate this phase voltage, multiply by √3 will be the line voltage. So you can get the line voltage, divide by this 10 milliampere, you will get the phase current again. But that is not correct method. Why? Why not correct? Because this is DC supply. In DC supply, line voltage and phase voltage method is not applicable. So that's correct answer is 1 milliampere. So this was easy peasy. Let's move to the next question, guys. Let's move to the next question, and the next question is we have the next question, and the next question is from machines. Okay, so let me see that question, and then let's try to solve that question also. So there is one question from electrical machines. Let me first solve that question. Yes, I got that question. A short circuit test is conducted on a single phase transformer. We have a single phase transformer. Okay, we have a single phase transformer. This is my single phase transformer. Okay, and we have performed a short circuit test, and we have sorted this secondary side. Okay, it is given that the frequency of the input voltage is 1 kilohertz. The frequency is 1 kilohertz. Okay, this is the supply frequency, and the frequency is 1 kilohertz. The corresponding wattmeter reading, the primary current and the primary voltage. Okay, on this side we have calculated the wattmeter reading, that is 8 watt. Okay, so the wattmeter reading is 8 watt, and the current from the primary side, current is equal to 2 ampere, and the voltage applied on the primary side is 6 volt. Okay, under the short circuit test, this is the supply voltage, this is the current, and this is the power, okay, which is consumed by this circuit. Now it is given that, assume that the no load losses and the no load current negligible. He's saying that we don't have to take no load losses. It means RC and XM is neglected. We don't have to take RC and XM. Okay, if you remember, in transformer we have RC and JXM, so we don't need to take that part. Okay, I mean this part is gone. There is no loss. No load losses are 0. Okay, and the core has linear magnetic characteristics. Okay, so the BH curve is linear. It is given that the BH curve is linear. BH curve is linear. Current versus flux curve is linear. That's perfect. Keeping the secondary sorted, the primary is connected to 2 volt. Now what he is doing is he is connecting the primary to 2 volt. Okay, and it is sorted here. So it is he is connecting the primary to 2 volt RMS value. Okay, this is 2 volt RMS value in series with a capacitor. In series with a capacitor, there is one more capacitor connected here, and the capacitance value is 1/2 pi root 5 millifarad. Okay, this is the capacitor connected in series. Okay, the primary current, I need to calculate the primary RMS current. What is the primary RMS current? We need to calculate that. So again, it's a very simple question, guys. Now in this question, 2 concepts are merged. One is machines, electrical machines, and the second one is resonance. Okay, so let's try to solve this question. First, the short circuit data is given to you. Using that short circuit data, we can calculate the equivalent resistance from this side. Okay, we can calculate the resistance seen from this side, or rather the impedance seen from this side. Now how to calculate the Z equivalent, impedance seen from this side? Tell me, guys. The impedance seen from this side will be voltage upon current. So the impedance Z equivalent magnitude will be equal to 6/2, that is 3 ohm. Okay, this is the magnitude of impedance. Okay, and we know that in impedance there is one resistance and one reactance. X equivalent plus R equivalent plus JX equivalent. It will be my Z equivalent. Okay, the magnitude is given as 3 ohm. Now I need to calculate the resistance part and the reactance part. How to calculate that? Using that power. We know that the power can be consumed only in the resistance, and the RMS current is 2 ampere. So IRMS square into R equivalent, that has to be equal to 8 watt. What does it mean? It means R equivalent came out to be 2 ohm. You can see that R equivalent came out to be 2 ohm. If R equivalent is 2 ohm, we can calculate X equivalent by the magnitude expression. We know that the Z equivalent magnitude is 3. What is the Z equivalent magnitude? You can take the square of that. That is R equivalent square plus X equivalent square is equal to Z equivalent square. That is 9. So X equivalent came out to be root 5. I hope it is clear. So you can see that the impedance seen from this side, when the transformer is sorted, the impedance seen from this side is 2 plus j root 5. Okay, so the impedance seen from this side is 2 plus j root 5. 2 and j root 5. Okay, plus j root 5. This is the equivalent impedance seen for the short circuit transformer. Okay, if the transformer is sorted, from this side you will see this impedance. Now what you are doing is you are connecting a capacitor. And a voltage source. Okay, 2 volt RMS value. Now I need to calculate the RMS current. To calculate the RMS current, I need to calculate the capacitive reactance. Okay, and what is the capacitive reactance? It is 1 upon j omega. Omega is 2 pi f. F is 1000 1 kilohertz. So 1000 hertz. Okay, so 2 pi f. This is omega. 1 by j omega c. C value is given as 1 by 2 pi root 5 into 10 to the power minus 3. Okay, so I have put the value of C and I have calculated the capacitive reactance. So this 10 to the power minus 3 will is gone. Root 2 is also gone. So it will become minus j root 5. Okay, so the capacitive reactance at this frequency, the capacitive reactance came out to be minus j root 5. Now tell me guys, what is the current now? What is the current? The current will be very simple. This minus j root 5 and plus j root 5 will cancel. The total impedance will be 2 ohm. So 2 volt divided by 2 will be the RMS current. RMS current came out to be 1 ampere. Is it correct guys? Tell me guys, is it correct? Answer is 1 ampere. Raspian is correct. Raspian is saying correct answer. Answer is 1 ampere. So this was again very simple question. I mean not that simple. If you know the machines and if you know network theory, then you can easily solve this question. Let's come to one more network question, and it is this question is based on magnetically coupled circuit. Okay, let's try to solve that question also. So let's take that question. We have 2 coils which are magnetically coupled. It is given to you. It is given like this. Okay, and this current is I1T. This current is I1T and this current is I2T. Okay, we are provided with these 2 current, and this I1T is given as 1 sine of 200 pi t. 200 pi t milliampere. Okay, I1T is given as this, and I2T is given as 2 sine of 200 pi t milliampere. Okay, this is my I2T. Okay, the coupling coefficient between the inductor is given as 0.6. Okay, okay, it is also given that this self-inductance is 4 Henry and the other self-inductance I2T, this is 5 Henry. I think this is correct guys. I think this is correct. Okay, so one inductance is given as 4 Henry, one is 5 Henry, and the coupling factor is 0.6. This current is sine of 200 pi t, and this current is 2 sine of 200 pi t. Now the question is the peak energy stored in the inductor in the circuit. Okay, in the coupled circuit, what is the peak energy stored? Now tell me, in a coupled circuit, how to calculate the energy stored? The formula for no, you can see that this current is leaving from this dot. I mean the coil current. The coil current is coming down. Here also the coil current is coming down. So from the dot point, both the currents have same direction. Okay, with respect to the dot point. So now the energy stored in the coupled coil will be half L1 I1T square plus half L2 I2T square plus M I1T I2T. If you remember, I1T I2T. This is the instantaneous energy stored in the coupled coil. But we require the maximum energy stored. What does it mean? The maximum energy will be there when the current will achieve the maximum value, okay, when these currents will achieve maximum value, and you can see that these two currents are in same phase, they are in same phase, so they will have maxima at the same instant. The maxima for this current is 1 ampere and the maxima for this current is 2 milliampere. So what we can do is we can put the maximum value of the currents and we can calculate the energy stored in the coupled coil, okay. But for that we need to calculate the mutual inductance M. How to calculate the mutual inductance M? We know that the coupling factor must be equal to M divided by root L1 L2, okay. So from here we can calculate the mutual inductance value. So M came out to be 0.6 root of L1 L2, okay, and root L1 L2 is if you multiply them then it will become root 20, okay. So it will become 0.6 root 20. I hope it is clear, guys. Okay, so this is my mutual inductance. This is my mutual inductance. Now what we can do is we can put the value and calculate the maximum energy stored in the coupled coil. So it will be 1 by 2 L1. What is L1? L1 is 4 Henry into the maximum value of the current, that is 1 milliampere. So take the square of 1 milliampere. 1 square is 1 and milliampere square is micro. So this energy is in microjoule, okay, plus this part, this is 1 by 2 L2. What is L2, guys? What is L2? L2 is 5 Henry, okay, into I2 square. At the instant when this current will reach the maxima, at the same instant this current will reach the maximum because they are in the same phase. So you can say that the current square is 4 here, okay, I2 square is 4. Is it fine? Plus M. M is 0.6 root 20 into I1 I2, into I1 I2. I1 value, max value is 1, I2 value is 2, okay, so the product will be 2. Is it fine, guys? Now we can calculate this answer. So this will be 2 here plus half L2 and okay, this will be cancelled here, so it will become 10 plus this value 1.2 root 20, okay, this much of microjoule. This much of microjoule. Why microjoule? Because the current has milliampere value, and we have squared it. So milli square, 10 to the power minus 3 square is 10 to the power minus 6. That is microjoule. Now you can take the sum of these two values. So 12 plus 1.2 root 20. Okay. Answer came out to be 17.37. 17.37 microjoule. I hope it is clear to everyone. Tell me, guys, is it clear? Tell me, everyone, how many of you have done it? How many of you have solved this question? Tell me, everyone. Sir, there was having two sum option. Will it be empty? MTA. Okay, Chandrasekhar, we will see that question. We'll look at that question also. We'll tell you. Don't worry. So this is one network question, and I hope everyone has solved this question. So this was very simple question. Energy stored in the coupled coil was asked. Okay. Let's move to the next question, guys. And the next question is from analog electronics. Okay. So let's try to solve analog electronics questions. Okay. Now we have one analog electronics question. Okay. Before that, there is one wattmeter question is also there. So that question was again very good. Okay, and maximum student have done the mistake or they have left that question. So the question is there is a diagram which is provided to you. Okay, there is a diagram which is provided to you. We have a transformer. This transformer is 2:1. Okay, and here we have some resistance, and there is one more transformer 1:1. Okay, there is one more transformer that is 1:1. Okay, and we have some wattmeter which has current coil connected like this. This is current coil, and there is one potential coil. Okay, this is my potential coil PC, and the potential coil is connected like this. One point is connected here, the other point is connected here. Okay, so we have this wattmeter. This is my wattmeter. Okay, this is my wattmeter. Now here we have the source. Here we have the source. Now the question is the full scale range of the wattmeter shown in the circuit is 100 watt. The full scale is 100 watt. It can measure up to 100 watt. Full scale is 100 watt. It is given to you. The turn ratio of the individual transformer are indicated in the figure. The RMS value of the AC source voltage is 200 volt. This is 200 volt. Okay, this is 200 volt. The wattmeter reading will be, tell me, guys, what will be the wattmeter reading? Tell me, everyone. Let's see how many of you have done it. What will be the wattmeter reading? Tell me, everyone. What will be the wattmeter reading? Everyone, tell me. Tell me. Please comment. What will be the wattmeter reading? Is it 100? Samir is saying 100. Okay, anyone else? This was NET question, I suppose. So tell me guys, what will be the wattmeter reading? Is it 100 or something else? Tell me everyone, what will be the wattmeter reading? This is very good question. This is very good question. Let's see how many of you have solved it. Tell me everyone, what is your answer? Do it fast. Tell me how much power you have written. What is the reading of this wattmeter? Okay, Raspian is saying I don't know. Answer is 0. 0 watt. Answer is 0 watt. Why 0? Tell me why 0? Answer is 0 watt. Why? Why it is 0? Tell me guys, why the answer is 0? Because this is a KCL question. Now you can see that according to KCL, you can say if this current coil, one point is connected here and the other point is connected here, there will be 0 current in the current coil. Why 0 current? Why the current will be 0? Because KCL says that this is a closed circuit and this is a closed circuit. If some current is leaving from the closed circuit, then there must be entering current should also be there. Since there is no other connection, so obviously the current leaving will be 0. Okay, I hope it is clear to everyone. Tell me guys, have you understood this point? I have performed an experiment on the same question. Okay, I have performed experiment. If you have seen my experiments, I have performed one experiment. You can see that this is a closed circuit. This is a closed circuit. In the closed circuit, if there is a leaving current, then there must be entering current. But there is no entering path. There is no return path from this circuit to this circuit. There is no return path. So the leaving current will also be 0. So this current is 0. It means in current coil, you don't have any current. Okay. If there is no current, then the wattmeter reading will always be 0. Okay. So the answer is 0. Now, whoever made it, I don't know what IIT is providing you. Okay. Whatever answer they are providing, I don't care. But the thing is, they might provide you some numerical value. They can, I mean, the designer, whoever designed this question, who might think he might think that he or she might think that there is a current flowing. There is a current flowing, and according to that, he can give you the answer. But that answer will be wrong. Answer is 0. Okay, answer is 0. We can claim it. Okay, if the answer is other than 0, we will surely claim it, because I know that there are some teachers who don't believe on this part. Okay, so don't worry, we'll claim it. Answer is 0. Answer is 0 watt. Okay, let's come to the next question, guys. So the next question is from analog electronics. Okay, next question is from analog electronics. So let's try to solve the analog questions. This is operational amplifier question. So let's try to solve this question also. So the question is, let me draw the diagram. So we have one operational amplifier. Let me change the color. Okay, we have one operational amplifier, and the operational amplifier is like this: negative terminal, positive terminal, and we have a resistor connected here. This was again very good question. Okay, this was again very good question. R, this is R, and there is R also. R is connected here also. Okay, and this is connected here, and this is grounded. On this side, we have 1 volt voltage source. We have 1 volt voltage source, and we have 3R here. Here we have 3R, and this resistance is also provided as 3R. Okay, and this point is grounded. We need to calculate the voltage V0. What will be the value of V0? So again, it's a very simple question. It is given that the op-amp is ideal. The op-amp is ideal. So let's calculate this question, guys. This is again very simple. What you need to do is, you need to calculate this voltage, because there are both the feedbacks, positive as well as the negative. So both feedbacks are present here. So what we are going to do is, we will try to calculate this voltage. Once you get this voltage will be known. We are assuming that the op-amp is not saturated. If op-amp is not saturated and positive as well as the negative feedback both are provided, then it doesn't matter, guys. If op-amp is not saturated, then you have to take the virtual sort point. Okay, I mean this voltage and this voltage you have to take equal. Generally, students think that if the positive feedback is there, then the op-amp will always be saturated. It will not be like this, because only positive is not there. There is also a negative feedback. So I'm assuming that the output is not saturated because the saturation level is not given to you. If the saturation level is not given to you, it means you can assume that the voltage is not saturated. And if the voltage is not saturated, you can assume that this point and this point has the same voltage. So it's a virtual sort concept you have to apply. So once you get this voltage, you can easily calculate this voltage, and then you can calculate the output voltage. Now, how to calculate this voltage? Using nodal. Let's apply nodal. So this resistance is, let me check the value of this resistance first. Yes, this resistance is 3R, okay? This resistance is 3R. Now, let's apply the nodal and try to calculate this voltage. So it's very simple. We know that this voltage is V0 and this voltage is 1 volt. Let's call it VA. Once you get this VA, then you can easily calculate the current and you can easily calculate this voltage. So let's try to calculate the VA. You can directly write the nodal equation. Tell me the coefficient of VA. The coefficient of VA is 1 by R plus 1 by R plus 1 by 4R. Okay. So 1 by R plus 1 by R plus 1 by 4R equal to entering current. Tell me the entering current, guys. The entering current from this side will be equal to 1 divided by 4R. This is not a junction point. This is a node point because there is no current entering in the op-amp. So you can say this is 4R. So 1 divided by 4R is the entering current. 1 divided by 4R is the entering current on this side. And V0 upon R is the entering current from this side. V0 upon R. Now this R will cancel. Okay. This is direct nodal equation. If you know this direct nodal equation, you can easily write it and your time will be saved. So the coefficient of VA will be 1 plus 1 plus 4 by 1 by 4. So it will be 9 by 4 is equal to 1 by 4 plus V0. Now you can calculate VA as 1 by 9 plus 4 V0 by 9. So we have calculated this voltage. Once you get this voltage, now you can calculate this current. Using the nodal, you can calculate this current, and that current will be 1 minus VA. VA is 1 by 9 plus 4 V0 by 9. Okay, this is the voltage difference. 1 minus VA divided by the total resistance of this path. Total resistance is 4R. So 1 upon 4R. This is the current which will flow via this path. This current multiplied by 3R is the voltage drop here. Okay, multiply by 3R. This is the voltage drop here. Now, what is this voltage, guys? This voltage will be 1 minus this drop. 1 minus this voltage drop. Okay, we'll get this voltage. So let's calculate this voltage first. So this R is gone. So this will be 1 minus 3 by 4. Now you can calculate it quickly. 1 minus, that will be 1 by 9 minus 4 V0 by 9. I hope it is clear. Okay, if you can solve this question, this part. So let me solve this. So it will be 1 minus 3 by 4. That is 1 by 4. 1 by 4 plus 1 by 12. 1 by 4 plus 1 by 12 minus this 4 will cancel, and there is one more plus. Okay, so plus this 4 will cancel and V0 by 3. Okay, I think this is correct. So we have calculated this point voltage, and the same voltage will appear here. Okay, now if let's call it Vx. Let's call it Vx. If you know this Vx, this voltage will also be Vx. What about this current? This current will be Vx by 3R. And the same current will flow from this resistance because there is no current which come out from this op-amp. So the same current will flow from here. So you can see that this voltage is Vx by 3R into 3R. That is again Vx. If this point is Vx plus Vx, this voltage will be equal to 2Vx. It means V0 has to be equal to double of this value. Okay, double of this value. So you can write it like 2 into 1 by 4 plus 1 by 12 plus V0 by 3. Is it correct, guys? Now what you can do is you can take this 2 V0 by 3 on this side. If you take this 2 V0 by 3 on this side, then it will be V0 by 3 is equal to, on this side you have 2 into, what is this this ratio? So LCM is 12. LCM is 12. This will be 3 plus 1. That is 4. Okay. So this is cancelled with this 6 and this 3 is 2 and answer is 2 volt. Okay. So V0 came out to be 2 volt. This was very good question. Very good question. Okay. Only based on nodal, KVL, KCL. Okay. So answer is 2 volt. How many of you have corrected it? Tell me, guys. How many of you have corrected it? So this was again very basic question. KVL, KCL, nodal. Okay. So let's come to the next question. Next question is again from operational analog electronics. So let's try to solve that question also. Wait a minute, guys. Let me check. Yes. Yes, I have one more question on operational amplifier. So let's try to solve that question also. Wait. I think that question is gone. So I don't know where to open the slides. Wait a minute, guys. Let's see. Yes, I got that. I got it, sir. Okay, let's try to solve one more question, guys. There is an ideal op-amp, and the ideal op-amp is shown in the figure. So let me draw the figure. So the figure is minus plus, and the negative feedback is given to you. And here you have the grounded point. This is 1 kilo ohm. This is 1 kilo ohm, and there is one more resistance, and this resistance is 100 kilo ohm. 100 kilo ohm. Okay, and we have this point grounded. Okay, we have this point grounded. Now the question is, the ideal op-amp shown, except it has input bias current of 1 nanoampere. Input bias current is given to us. Input bias current. Input bias current is 1 nanoampere. Okay, input bias current is given as 1 nanoampere, and the offset voltage. The offset voltage is given as 10 microvolt. 10 microvolt. Okay. Now what I need to do is resulting worst case output voltage. We need to calculate the worst case output voltage, V naught T. Okay. How to calculate that, guys? First of all, let's look at the voltage due to offset voltage. Voltage due to this offset voltage. Now we know that due to the offset voltage, if you want to show the offset voltage, then you can easily show it here at the positive terminal. This is VOS. This is you can say imperfection in the ideal op-amp. Okay, so this is VOS. You can take it ground, and here you have 1 kilo ohm. This is 1 kilo ohm, and you have 100 kilo ohm. Okay. Via this circuit, with the help of this circuit, you can calculate the output voltage due to the offset voltage only. So let's try to calculate the output voltage. We know that this is negative, this is positive, so there is a negative feedback which is working. Now virtual short concept will be applicable here. So this point is VOS, so this point will also be VOS. Okay, this point will also be VOS. Now you can calculate this current, VOS minus 0 divided by 1. So the current will be VOS divided by 1 kilo ohm. This is the current. Now op-amp will not provide you this current. So this current entirely will come from this side. So what is the voltage drop here? So the voltage drop is this current into 100 kilo ohm. Okay. So this will be 100 times of VOS. Now this point is VOS and this voltage is 100 VOS. So what is V naught? V naught will be 101 VOS. Okay. And VOS is, what is the value of VOS? 10 microvolt. So if you can multiply, if you can put the value of VOS, so it will be 1010 microvolt. This is the output voltage due to offset due to this VOS. Okay. Now we need to calculate the output voltage due to the bias current also. Now what is the bias current? We can assume actually in operational amplifier we have two currents. Okay. If the operational amplifier is not ideal, then we have two currents. One is IB1 and one is IB2, and the input bias current will be equal to IB1 plus IB2 divided by 2. This is my input bias current. Okay. Now what we can assume is, we can assume that this current is 0. In the worst case, this current is 0 and the total bias current is this IB1. Okay. So what we can take is, now we can take this 1 nanoampere as the input current of this operational amplifier at this terminal. So now let's try to calculate the output voltage due to this input current, input bias current. And I am assuming that IB2 is 0. Okay. IB2 is 0. Or what you can say is, you can say that this bias current has to be equal to, I mean, you can take this IB1 and IB2 equal. That will also be the other case. Okay. You can also take equal, and that will be the worst case, I suppose. Okay. So if you take it like this, minus plus, and this will be grounded here. Now what I'm taking is, what I'm assuming is, I am assuming that this is grounded, okay, and this is 1 kilo ohm. Now I'm assuming that this current is 1 nanoampere, because this will be the worst case. Okay, I'm assuming that this current is 1 nanoampere. I'm assuming that this IB1 is equal to bias current, because I'm assuming that this current and this current are equal. Okay, if they are equal, then take the sum of that, divide by 2, the 2 will cancel, and IB1 is equal to the bias current itself. Okay, so I'm assuming that this current is 1 milliampere and this current is also 1 nanoampere. This current is also 1 nanoampere. Now, what is the output voltage due to this current? We know that if this is 0, this will also be 0. If this is 0, this will also be 0 according to virtual sort concept. This point is 0, this point is also 0, so there is no current from this side. So the entire current will come from this side, okay? This 1 nanoampere, that entire current will come from this side. And this is 100 kilo ohm. So what is the voltage drop here? So that voltage drop will be 1 nanoampere into 100 kilo ohm. Okay, so it will be 100 into 10 to the power 3 into 10 to the power minus 9 volt. This is the voltage drop here. So if you calculate this value, this will be 10 to the power 5 into 10 to the power minus 9. It came out to be 10 to the power minus 4 volt. Okay, 10 to the power minus 4 volt. This voltage. Now what is the output voltage? This point is 0 volt because of virtual sort. If this is 0, this will also be 0 plus this voltage. So the output voltage came out to be, due to this input bias current, the output voltage came out to be 10 to the power minus 4 volt. Okay, 10 to the power minus 4 volt. Now what you can write it, okay, we need to calculate the total voltage. We need to calculate the total voltage. We have to apply the superposition, because the offset voltage and the bias current, because of that we need to calculate the total voltage. So the total voltage is in microvolt, we need to calculate. So if we can convert this in microvolt, tell me guys, what is the value of this in microvolt? 0.01 microvolt, is it correct? 0.01, I think this is correct, 0.01 microvolt. Now we can add them. Now we can add this and this. If we are going to add them, then you can see what is this value. I think this is, tell me guys, what is this value in microvolt? This plus this. I think I have done it correctly. Is there any mistake? 10 to the power minus 4, I think it is correct. I think it's correct. Okay, okay. So I think it's correct, sir. Wait a minute. Oh. So this is wrong actually. So this is 100 into 10 to the power minus 6. This is 100 into 10 to the power minus 6. It means this is 100 microvolt. So 100 microvolt plus this, we have to add them. Okay. So this is 1010 plus 100. Okay. So it will be 1110 microvolt. So this is the correct answer, guys. 1110 microvolt. Is it correct, guys? Tell me. 1110 microvolt. So that question was very simple. Okay. I mean, within just 30 seconds you can answer that question. So the question is, an LED emits light when it is, LED will emit light when it is biased. Now tell me, when the LED will emit light, obviously when it is forward biased, because the LED is same as the diode, na? So LED will give you the light only when it is forward biased. Okay, so answer is forward here. Okay, and the photodiode. A photodiode provides maximum sensitivity to light when it is reverse biased. Okay, the photodiode will work when it is reverse biased. Okay, so the answer is, I think, Calcutta. One is forward, one is reverse. Okay, photodiode has to be reverse biased. Okay, reversed biased, reverse biased. Okay, so the answer is Calcutta. Answer is Calcutta, because I think Calcutta is provided forward and reverse. I don't know in your exam which option was forward and reverse, so you can check it. So this question was again very simple. So let's sir. Okay, so the next question is from again analog electronics. Analog, sir? Yeah. Analog electronics, and MN sir will continue from this point onward. So okay guys, tell me how many questions you have corrected till now. Tell me everyone, how was your exam? And don't forget to like this session. Please share this session to everyone. Tell me guys, how was your exam? How was your exam? Tell me everyone. Oh, no, sir, this is wrong.
Yeah, let's see another question. Yeah,
Just wait.
I think we logged out. We are getting the question. It is already typed and available. I don't have the question directly. Let's see the question, what it is. It is also from analog circuits. I think some students comment by the time we log in and check this. Let's see the questions. Forward bias, yeah, the question what just discussed is LED. It's a very basic question. No? The students who follow EDC is very simple for them. It is LED is always emits the light in forward bias condition, and photodiode is operated in reverse bias condition. Please log in here and show the PPT. That is one thing, and the another question is also from analog circuits, which is MOS field effect transistor question. Okay. I always told you, we can expect every time we can expect 1 or 2 questions from op-amp. So this year I think there are 3 questions from op-amp, 2 or 3 questions, and there is a question from MOSFET as well. So it will be there. Always MOSFET questions are very, very important for us. So let me show you a MOSFET question, because already Ashu Jangra has solved the op-amp questions. So easy, na? So people are saying that the question papers are easy. Questions are easy. That's good. One way it is good, one way it is bad. I say if the question paper is easy, then everybody will write the questions easily. So question paper is difficult is always better for students' point of view. Yeah. Yeah, this is a question given from MOS field effect transistor. Hope this question is visible to you. Yes. Figure below shows a feedback amplifier constructed using an NMOS transistor. This is an NMOS transistor. Don't think that the arrow is inside. It's not PMOS. Okay, this arrow we have to see. This is a substrate. Substrate is generally connected to the source. So this is drain terminal here. This is gate terminal here, and this is source terminal here. Assume that mu n COX is 1 milliampere per volt square. This one is given, mu n COX. Threshold voltage. Sorry for this typo error. This is threshold voltage. Threshold voltage is given 1 volt Vt. W by L is 2. Width length ratio is 2. The bias voltage at the drain terminal is 4 volts. Vd, drain voltage is given 4 volts it is. Bias voltage means DC voltage, right? So the voltage here is given. This is very important to note. 4 volts it is given. So from this we can find the current, in fact. The drain bias current we can find. The capacitor C infinite offers 0 impedance at signal frequency. That means the effect of this capacitance, this is also C infinite it is. For the signal frequency, the capacitor acts as short circuit. That's what given. Even we can consider this capacitor also short, right? Sir, I did silly mistake. Rityanksha. Okay, that sometimes happens, don't worry. Right, this is the data given. Now what is the question asked? The ratio V0 by Vin. That is nothing but AV. The voltage gain of this amplifier is given. Feedback amplifier. First of all, what amplifier it is? Just try to solve it in a shorter time. I gave you, when I was taking these analog circuits and especially amplifiers, I gave you the direct formulas also how to solve it in very short way. So first thing you have to identify is what amplifier it is. You can see the input is given at gate, output is taken from the source, right? Output is taken from the source. So what it is? It is a common drain amplifier. When input is at gate, output is at source, it is common drain amplifier. And what is asked for common drain amplifier? It is voltage gain. So what is AV? It is GMRS by 1 plus GMRS. This is the direct expression you must have already derived while analyzing this amplifier. If you remember this expression, you better directly apply in this formula and get the answer. If you don't remember this formula, then I'll show you how to derive this during the examination hall. I don't suggest to derive, but if you don't remember this, or if you have a doubt whether it is correct or not, then you can directly go for solving that also. It's not that complicated, it's very simple. From this you can also understand the answer is somewhere close to 1. It is slightly less than 1 because it is GMRS divided by 1 plus GMRS. So the answer must be less than 1 always. But for CD amplifier, voltage gain is always less than 1. If it is a MCQ, we would have found the answer directly by seeing the options. Since it is NAT, we have to give the correct answer. Let's find it. So this expression needs GM for us, right? GM is needed. RS is given. RS is 1K given already. RD is given. Only one parameter we don't know is GM. So what is GM? You can write the expression for GM is equal to mu n COX W by L into VGS minus VT is the expression for GM. How did we get it? By differentiating the ID expression in saturation for a MOSFET with respect to VGS. Change in ID with respect to change in VGS gives you GM. So this GM is required for us. Now what is given here? Mu n COX is given already, 1 milli. So it is 1 into 10 power minus 3. W by L is also given, it is 2. As per the data it is 2. Into VGS we need to find. VGS is not given here. Remember guys, this VGS is not given. VT is given. So let's find what is VGS. VGS is the bias voltage it is. The voltage between gate, this is the gate and this is source. Gate to source voltage, VGS we need to find. The bias voltage, the DC voltage we need to find. So that has to be found separately. For finding the DC voltage, we can assume that this capacitor is open, this capacitor is also open. Then what is VGS here? VGS is nothing but VG minus VS, right? So what is VG? The voltage here at the gate terminal. As you know, the gate current is 0 always. For a MOSFET, we can take the gate current 0 as there is an insulator in between. So these two resistors comes in parallel. Once this resistor is open and this current is 0, then VG can be written as, the voltage here can be written as 5 into voltage division, it is just 300K divided by total resistance is 500K. Right, this is 3 volts minus Vs. Vs is what? The voltage at source, which is nothing but ID into Rs I can write. As Rs is given, the current flowing, the DC current flowing through this resistance into Rs is the value of Vs there. So 3 volts is the Vg we found, but what is ID? We know Rs, but ID is not known. But ID can be found from this because Vd is given. This is the current ID flowing here. So what is ID? I'll write it here. What is ID? It is very simple. ID is this voltage, which is supply voltage 5 volts, minus this voltage, which is 4 volts, divided by the resistance is 1K. So it is 1 milliampere. So it is 1 milliampere into Rs is 1K. So it is 1 volt it is. So it is 2 volts. So VGS we found is 2 volts. So it is 2 volts minus Vt is given already 1. So this gives you 2 milliampere per volt is the GM. Done. What you just need is GM because Rs is known. So find the value of AV. AV is equal to GM. It is 2 milli into Rs is 1K divided by 1 plus 2 milli into 1K. This is the answer for this. Please solve this and check the answer. Must be 0.9 something. Can someone give the answer for this, guys? Calculate this. It is 2 divided by 3 it is. 2 by 3 it is, right? That should be the answer, but put it in decimals because it is NAD. If you don't remember, one extra point, if you don't remember this expression for this, you just draw the AC equivalent model of this 0.6. Is it correct? Please check it, guys. Once I think it should be close to point. Did we do all the things correct here? Because I doubt we should get it as close to 0.9 something. Did we make any mistake here? VD is 4, ID is 5 minus 4, 1. GMRS by 1 plus GMRS. Yeah, if it is so, then should be correct. It should be 0.67, no? That should be the answer, guys. Please check it. KKS is saying 0.952. That's what I am thinking. Actually, this answer should be close to 1. So, did we make any mistake anywhere, or the data is giving the same answer? Okay. By the time let Ashutosh discuss one more question, I'll check and get back to you if at all any calculation mistake is done. VGS is this. Yeah. I think it is looking correct, but let me check the calculation once again. You have any question to solve? Yeah, please.
Thank you so much, sir. Aman sir will be coming once again because I think there is some calculation issue. But I hope you guys must have solved this question. So friends, I will be discussing verbal ability part, and two questions I will be discussing from verbal ability part, that is from your aptitude section. One question I will be discussing from aptitude, and 2 questions I will be discussing from optical instrumentation. They were quite easy questions, so let us go through the questions. Yeah. So this was the question to confuse you a little bit, because if you see, if you have to find the quantum efficiency is given as the number of electrons collected number of electrons collected, I think it is, sorry, it is incident photons, na? So I think there is something wrong in the question. The question, I think this data is wrong. Please confirm this value. I think incident photons are given 4 into 10 to the power 12, and average electrons connected, this is actually 8 into 10 to the power 12. Please confirm this. So peak energy question I will be coming up later, okay? Yeah, 10 to the power 12. So it is going to be number of incident photons divided by number of electrons collected at the terminal. So if you write it, I think it is going to be 4 into 10 to the power 12 divided by 8 into 10 to the power 12 multiplied by 100, you will be getting it around somewhere 50%. So I think D should be the correct answer. And let us go to the next question. Very fast I will be going, sir.
Can we go to the previous question?
Okay.
Can we go to the previous question what I discussed? Because
Yeah.
one small calculation mistake we have done.
Okay, sir. Okay.
There it is.
Let me just.
Exit.
I think. I think still it is exit is.
Okay, okay. Let me take note and I'll do it.
Okay, no issues.
One small calculation mistake we have done, guys. In
Sir.
this question, what we have done. Yeah.
So the mic.
this question, what we got here, this is 1K given now. This is 5 volts, and I guess this is 300K, and this is 200K. Right, this is the capacitor and output. This is 1K. This is 1K. Here is the capacitor, and here is VI. VI or VS. Asked to find VO by VI. Just I told you it is GM RS by 1 plus GM RS, right? So our point is to find GM, which is mu n COX W by L into VGS minus VT whole VT. So mu n COX W by L is given 5, I guess, right? It is 5 or 2, whatever. So can you please check it, guys? What is the mu n COX W by L? Mu n COX is given, I think it is 5 milliampere per volt square, milliampere per volt is given. Let me check this. Huh? So what is the value of mu n COX is given? Mu n COX. Ashu, can you check the value of mu n COX given here in this? This question, I think you must have seen.
Just a moment.
Guys, by the time, can you also please comment what is the mu n COX value given? I don't have the data with me right now. W by L is 2 given, I remember. Mu n COX W by L into VGS, we found it is 2 volts, right?
Yes,
minus VT is 1.
Mu n COX is 1 milliampere per volt square.
This
mu
is
n COX is 1 milliampere per volt square. 1 milli, 10 is 1 minus 3.
of course 1 milli.
Ampere per volt square. That
Okay,
is the
okay.
dimension.
W by L is 2, right?
W by L is 2.
VGS we got is it is 3. This is 1. So it is correct. So it is 2, right? Something is missing here. It is 1 milliampere per volt square, right? Sure. So this is 1
Into 2.
milliampere per volt, it is, right? GM. So then it should be, this is 2 into 1 by 1 plus 2 into 1. 2 by 3, no? Check the guys, if GM is 1 milliampere per volt square, this is the correct answer. But I got some other questions saying that mu n COX is given 5 milliampere per volt square. Which one is correct? If this is correct answer, then it is VO by VI is, if that is 5, then it is 10, right? So GM will be 10 in that case. So it is 10 by 11 it is. So that is 0.9 something. If mu n COX is given is this, that is the answer. But if mu n COX is 1 milliampere per volt square, this is the answer. You decide now which one is correct. That depends on which data is given in the question. What I received in one question, because these questions are received from the students, I got it as 5 milliampere per volt square. So then the answer is 0.9. But now Ashu Changra is saying that the GM value is 1 milliampere, and even students are also saying it is 1 milliampere. Then the answer is 2 by 6. Please check it, guys. I'll once again check it.
Okay, sir, I have one more question.
Yeah.
Okay, guys, so the question is from analog electronics, and again, a very good question is there. There was one student who was asking, sir, in coupled circuit, that energy question, whether M will have the positive sign or negative sign. So M will have the positive sign because both the currents are leaving from the dot. They have the same direction. That's why M must be positive. Okay. So let's come to the next question. I told you that there is one MTA question. Okay. Remember that analog question. Because if the ground is, if output voltage is with respect to ground, you can easily claim that. Okay. I told you that. And in that question, ground is clearly mentioned. So obviously there is an MTA. Okay. So that's a good question, by the way. Let's take one more question, guys, and that question is again from analog electronics, and it is based on the capacitor circuit. So let me take that question. So please wait, let me find that question. Yes, I got it. Okay, so wait a minute, I have solved it somewhere. Okay, so please verify that question, guys. Let me write this. Okay, let me write the question. So the question is, we have one op amp like this. This is negative, this is positive, and this is grounded. And here we have the capacitor, and the value of the capacitor is 10 nanofarad. Please confirm that. Okay, and here we have the capacitor, and we have the switch. Okay, we have the switch here. Okay, guys, and this is V in, and V in is a square wave. V in is a square wave. It is changing like this. Okay, V in is changing like this, and the peak value is 100 millivolt. 100 millivolt. Please verify. And this is a switch S. This is position 1 and this is position 2. Okay. In the circuit shown, the input voltage V in is 100 millivolt. Okay. The switch and the op amp ideal. The switch and the op amp is ideal. Okay. And at the time t equal to 0, the initial charge stored in the 10 nanofarad is 1 nanocoulomb. Okay. So the charge stored is 1 nanocoulomb for this capacitor. So obviously the voltage, initial voltage is equal to Q by C. That is equal to 0.1 volt. Okay. 1 Q by Q, Q is equal to CV, na? So voltage across this capacitor will be Q by C. That is 0.1 volt. Is it clear, guys? The charge stored is 1 nanocoulomb. So according to 1 nanocoulomb, the initial voltage came out to be 0.1 volt. Okay. Next question is, next statement is with the polarity as indicated. Okay, this is the initial voltage polarity, and this value is 0.1 volt. Okay, as per the given data, according to that, this is 0.1 volt. Okay, the switch S is controlled using 1 kilohertz. Okay, the frequency is 1 kilohertz. It is given that the frequency is 1 kilohertz. The square wave voltage signal Vs shown in the figure, Vs is high. Whenever Vs is high, S is in the position 1. Okay, whenever Vs is high, this S is connected at position 1. Okay, fine. And whenever it is low, so high, if Vs is high, the switch is connected here. Whenever it is low, it is connected here. Okay, whenever it is low, it is connected here. Now the question is, at t equal to 20 millisecond, the magnitude of output voltage. Okay, we need to calculate the magnitude of output voltage at t equal to 20 millisecond. Is it correct? Question. Tell me, guys, is it correct? Let's not call it V0, let's call it V0. Okay, so initial charge was 1 nanocoulomb, and because of that initial charge, the initial voltage came out to be 0.1 volt. Okay, and the peak value is 100 millivolt or 200 millivolt. Tell me, guys, is it 100 millivolt or 200? Because some student is saying Dipto is saying it's 200 millivolt. Is it 200 millivolt? Tell me, everyone. I think it is 100 millivolt. V in is given as 100 millivolt. Now, can you tell me this capacitor value? What is the capacitor value? Because I don't know that, because my data is not fully correct. So can you tell me this value? What is the value of this capacitor? Tell me, guys. What is the value of this capacitor? Can you verify that? Tell me, everyone. Tell me. It's 1 nanofarad. Okay, thank you. 1 nanofarad. Now let's try to solve this question, guys. Let's try to solve this question. So again, this question is very good. Let's say this is high. If it is high, the switch is connected here. Okay. First of all, frequency is 1 kilohertz. So the time period will be equal to 1 over 10 to the power 3. This is my time period. So T by 2 will be equal to 1 by 2 millisecond. 1 by 2 millisecond. Okay. 1 by 2 millisecond means 0.5 millisecond. T by 2 is 0.5 millisecond, and T is equal to 1 millisecond. Is it clear, guys? Tell me. T is equal to 1 millisecond. So the time period is 1 millisecond. Now, in the question, it is given that I need to calculate at t equal to 20 millisecond the magnitude of the voltage V0. We need to calculate the magnitude V0 at 20 millisecond. It means after 20 cycles. After 20 cycles, we need to calculate the voltage. So let's try to calculate that. If you connect this switch position at 1, then 100, this capacitor will charge to 100 millivolt. Okay, this capacitor will charge to 100 millivolt. Now what you are doing is you are connecting this capacitor to this position. As soon as you connect this point to this position, this voltage has to be 0. Okay, because this is 0, so this has to be 0. It means what will happen? What will happen is we have a capacitor. This capacitor is charged for first 0.5 millisecond. For first 0.5 millisecond, this capacitor is charged at 100 millivolt. Okay, this capacitor is charged at 100 millivolt. Now you connect this capacitor to position 2. Okay, you connect this capacitor to position 2. So this will be the circuit now. This will be the circuit. Now we know that if it is 0, then this has to be 0. It means abruptly this voltage has to become 0. If the voltage of the capacitor is abruptly changing, then the current has to be impulsive. Now what will be the current? Can you tell me the current value? So the current value will be equal to, let's try to calculate the current value. So the current value will be equal to, we know that this is the capacitor. Okay, this is the capacitor and its initial voltage is 100 millivolt, and abruptly it is becoming 0. Now what will be the amount of current which will flow? Tell me guys. The amount of the current in Laplace domain you can calculate. So in Laplace domain the current will be, in Laplace domain the equivalent will be like this, 1 upon Cs. Okay, and this voltage will be 100 millivolt divided by S. Okay, so now if you are making it ground, then the current will flow, and the current will be 100 millivolt divided by S divided by 1 by Cs. So that Cs will come in the numerator. Okay, S will cancel. So you can say that in Laplace domain this current has to be 100 millivolt into C, and the C value is 1 nanofarad. So 100 millivolt, 100 into 10 to the power minus 3 into 1 nano, 10 to the power minus 9. Okay, so the current will be 100 picoampere. Okay, this will be the current in Laplace domain. In time domain it will be impulsive current. In time domain it will be impulsive current. Frequency was 10 kilohertz. Is it 10 kilohertz or 1 kilohertz? Tell me guys, please verify. What about the frequency? Is it 10 kilohertz or 1 kilohertz? Tell me everyone. What about the frequency? Please verify. So the current came out to be 100 picoampere. It means the current will be just impulsive current. Current will be impulsive and it will be in picoampere. Now if this current is coming like this, obviously this current cannot enter in the op-amp. The current cannot enter in the op-amp, so the entire current has to flow via this. Now tell me, what is the capacitor? What is the change in the capacitor voltage? The change in the capacitor voltage will be equal to this current into 1 by Cs. In Laplace domain I am asking. So in Laplace domain this capacitor is 1 by 10 into 10 to the power minus 9 into S. 1 by Cs is this. Multiply by this current. This current in Laplace is 100 into 10 to the power minus 12. I hope it is clear. Okay. So this is the change in voltage. This is the change in voltage. This capacitor voltage will change. And the change in voltage is this. Okay. So what is this change in voltage guys? So this will be equal to, now you can say that this is cancelled with 10 to the power minus 3. So in the numerator you will have 10 to the power minus 3, and this is 100, this is 10. So 10 into 10 to the power minus 3. So you can say that 10 to the power minus 2 volt. The change is 10 to the power minus 2 volt. It means 0.01 volt. This is the change. Okay. So when you connect this capacitor to this point, then the capacitor voltage will change by this much of voltage. Okay. Now tell me, you have 20 cycles because each cycle is of 1 millisecond, na? And you need to go with for 20 cycles. Okay. So in 20 cycles, if you multiply it with 20, then you will get 0.2 volt. You can see that the change in the capacitor voltage will be 0.2 volt. Previously, the capacitor was charged with this polarity. Now the change is of this polarity, and the change is of 0.2 volt. Now can you tell me the total output voltage? After 20 millisecond, after 20 cycle, the output voltage will be 0.1 previous voltage, the initial voltage, plus the total change. So if you are adding this, the total voltage after 20 cycle will be 0.1 itself with this polarity. With this polarity, okay? With this polarity, the voltage will be of 0.1 because previously it was of this polarity and the change is of this polarity, okay? Change is of 0.2 volt of this polarity. So the resultant voltage after 20 cycle will be 0.1 of this polarity, and the output voltage will be minus of 0.1 volt. Why it is minus? Because you are going from plus to minus. You are going from plus to minus because initial voltage was this. Okay, and now after 20 cycle it has become with opposite polarity. Okay, so now the output voltage will be 0 minus this change, minus this output, minus this capacitor voltage. So the output voltage has to be minus of 0.1 volt. Is it clear, guys? Tell me. Is it clear? Amplitude and input not given, just mention that high and low. Yes, I know that high and low, but high amplitude is given, I suppose. This is 100 millivolt. Okay, this is given as 100 millivolt. So let me again tell you about this question. So what I have done is, let me repeat this again from the initial point, because I don't know how many of you have understood this point. So let me repeat this question, guys. Let's use the next slide. Okay, the question was very simple. The question was very simple. This is grounded and we have one capacitor here, and the capacitor value was, tell me the capacitor value. So the capacitor value was 10 nanofarad here and 1 nanofarad here. Okay, this was 10 nanofarad, and here we have one capacitor as 1 nanofarad. Okay, at this point we have a source, and the source voltage is changing. Source voltage is changing like this. Is it clear, guys? Source voltage is changing like this. This is 100 millivolt and the frequency is 1 kilohertz. Okay, so if the frequency is 1 kilohertz, the time period is 1 millisecond. After 20 millisecond, we need to calculate the output voltage. Okay, this was the question, and the initial voltage is given as 0.1 volt with this polarity. Okay, polarity is mentioned in the question, so you can check the polarity, I think, and the initial charge is given as 1 nanocoulomb. So according to that charge, we can calculate initial voltage. So initial voltage came out to be Q by C. Okay, and Q is 1 nanocoulomb divided by C, 10 nanofarad. So you get initial voltage as 0.1 volt with this polarity. Okay, this is the initial voltage. Now just forget about this voltage. It's not required. When it is high, this point is connected here. It means this capacitor will get charged. If this capacitor will get charged, it means it will charge to 100 millivolt. Now if it is low, if the supply voltage is low, then it is moved to this point. It means now the circuit has changed. Now tell me, what is the circuit? The circuit is like this. This capacitor is charged and now it is connected here. Now this capacitor is charged and the capacitor has 1 nanofarad value and it is charged at 100 millivolt. Okay. Now we know that we need to calculate this current. We know that if this circuit is working, if this is 0, this has to be 0. It means as soon as you move this capacitor to this side, its voltage has to become 0. It means the current has to be impulsive. Now what is the value of the current? Current can be calculated as 100 millivolt divided by S divided by CS, and CS is, you can write 1 by CS in denominator or CS by 1 in numerator. Okay, that S is cancelled, so you can say that the current value will be 100 into 10 to the power minus 3 into this C value, and C value is 1 nanofarad, so 10 to the power minus 9. So the current came out to be 100 picoampere. Okay, so this is the current which will flow here, and this is in Laplace domain. Remember, this is in Laplace domain. In time domain, the current is impulsive. Okay, so this is 100 picoampere current which will flow here in Laplace domain. And what is this voltage, guys? This voltage will be equal to 1 by CS, 1 by 10 into 10 to the power minus 9 into S, 1 by CS into this current, and this current is 100 into 10 to the power minus 12. Okay, so you can cancel this. This will be 10 to the power minus 3 in the numerator, and it will cancel. So you can see that this is the voltage across the capacitor. Due to this charge, this is the voltage this is the voltage across this capacitor with this polarity. It is 0.01 volt. It means what is happening is, whenever you close this capacitor will charge to this voltage. Now if you remove it and then you connect it here, again it will charge to 100 millivolt, and then you connect it here, again it will supply this much of current and it will charge this further 0.1 volt. It means in every cycle this capacitor voltage will increase by 0.1 volt. Now we have 20 cycles because every cycle is of 1 millisecond, and we have 20 cycles. In 20 cycle, you can see that this capacitor will charge up to this into 20. Okay, this into 20. Okay, you can calculate this value as 0.2 volt. It means this capacitor will charge to 0.2 voltage with this polarity, and the initial voltage was this. So now you can superpose the initial voltage. You can add the initial voltage. So initial voltage was 0.1. and I'm taking it negative voltage, and this is the voltage which is charged due to the this is the voltage which came to this capacitor because of this capacitor. Okay, so the total voltage came out to be 0.1 volt. Okay, so the total voltage of this capacitor came out to be 0.1 volt with this polarity after 20 cycle. Now we know that this is 0 minus of 0.1. Tell me the output voltage. The output voltage came out to be minus of 0.1. Output voltage came out to be minus of 0.1 volt. I hope it is clear. Okay, so this is the answer, guys. Minus of 0.1 volt. Okay, or you can say 100 millivolt. Minus of 100 millivolt. Minus of 100 millivolt. This is the answer, because if the question is asked in millivolt, then you have to answer it in millivolt. 100 millivolt is the correct answer. Okay, guys. So, Asto sir, you are coming?
Yeah.
Okay. Okay.
So thank you so much, sir. It was very interesting question. I was also listening to this. So guys, I hope you are enjoying the solution. You are enjoying the live analysis. And just tell me in the comment section, how was your examination? So I am having just 2 questions from the optical instrumentation, 2 questions from the verbal ability part, and 1 question from the aptitude. So I'll be just, I will be just going to, just a moment. Yeah. Just a moment. Yes. So I think this was the question. So there was some misinterpretation of the input data. So I think it is written clear. Let me again, I was writing the equation wrong. So let me just correct it. The quantum efficiency of the photodiode is going to be given as the number of electrons collected at the terminal divided by the number of incident photons. Incident photons. Just tell me, you guys have done this question or not? So it was, I think, 4 into 10 to the power 12 divided by 8 into 10 to the power 12 multiplied by 100, that in percentage. So you must be getting 50%. The other data that is mentioned in the question is basically given to confuse you. Good afternoon, Aditi. How are you? Welcome to the session. So I hope you must have done this question. Now let us go to the next question. Now this was also a easy question. Yeah. So let us read what the question is saying. There is a silica glass fiber having a core refractive index. Core refractive index is given as 1.47 and a cladding refractive index of 1.44. He is saying if the cladding is completely stripped out, it means it is completely removed and the core is dipped into the water, having a refractive index of 1.33. Now water is playing the role of cladding here, so you can understand. So it is 1.33 given. Now he is asking what is the numerical aperture of the modified fiber. So you know numerical aperture is given as under root n1 square minus n2 square. If you put the values 1.47 square minus 1.33 square, as per my reference, you must be getting 0.458. Just confirm this value, 0.458. Everybody is getting this? 0.458. Yes, everybody? Are you getting it? Okay, so let's go to the next question. So this was a verbal ability question. It was quite direct, quite easy question. You can do it very easily. The village was nested. It is not L, it is nested. Okay, nested means it was situated in a green spot. Then there is a blank, the ocean and the hills. So this type of construct you can understand. It cannot be at, it cannot be in, it cannot be through, it can only be between the oceans and the hills. Very easy question. Let us see the next question. Yeah. 3. This is actually disagree. This is disagree. Okay, typographical mistake. It happens when we do it in a faster manner. This is agree. And you have to find the word which is closely related to the meaning. Now, if you see the relation between disagree and protest, if you disagree with someone, you will protest against him or her. Yes or no? This was the relation. Now, if you agree with someone, what you will do? Will you pretext? What is the meaning of pretext? Pretext means if you give pretext for any condition, it means you are giving excuses. So, if you agree with someone, you will not give excuse. So, this is wrong. Refuse means refuse, refute. When you refute somebody, you disagree with someone with a very high intensity. Refute means to completely discard what others are saying. So refute also cannot be the correct word, but recommend can be the correct word here, because if you agree with someone, you will recommend him. Whatever he is saying, you will accept that, yes, this is right. So there is one more question. That is your part actually, but you were involved in other questions, so I have solved it. You please check whether I am doing it correctly or not.
You have done means correct.
No. So he is saying residency is a famous housing complex with many well-established individuals. Many well-established individuals among its residents. A recent survey conducted among the residents of the complex revealed that all of those residents who are well-established in their respective fields happen to be academicians. So I think we can draw this diagram. Suppose these are the academicians. Then somewhere here it is going to be people who are well established. The statement says like that. Next, he is saying the survey also revealed that the most of these academicians are authors of some best-selling book. So if I draw it again, suppose these are the academicians and these are the best-selling book authors. Now let us check the statements. Some authors of best-selling books are residents of the complex who are well established in their field. Now understand, he is saying some authors of best-selling books. Now suppose this is that area. Some authors of best-selling book who are the resident of the complex and who are well established in their fields. Now this cannot be 100% correct with the certainty. Why? Because you see there are some people, academicians, who are not well established. And if they are not well established, they cannot be academicians. And if they cannot be academicians, they cannot be the best-selling book authors. So statement A is wrong. Statement B, all academicians residing in the complex are well established in their field. This is also wrong. Because all the academicians are not well established. Are you getting this? Only a part of them are well established. So this is also wrong. C option, some residents of the complex who are well established in their fields are also the authors of some best-selling book. No, this is wrong. Because this area which represent well established, this may be here. This may be here. So there may not be any overlapping with the well established and the best-selling authors. So this is also wrong. But option D is 100% correct. He is saying some academicians residing in the complex are well established in this field, and this is 100% correct. Option D. So D is the correct option. Over to you, sir. So guys, keep on sharing, keep on enjoying the session, and Rakesh sir is coming up, I think, signal system, sir.
So signals and 5 questions of signals, 1 control, 1 digital, 1 EMT, miscellaneous hai.
Too great, too great.
All right. Okay guys, chalo, let's move ahead then. So syllogism question, fantastically explained by the sir. And let me now go to my slide numbers. 18. So guys, almost maths question we have discussed. Control and digital also discussed. One question was left. बाद में आया तो उसको भी कर लेते हैं. 20 I think it is not 18. 20. Chalo, done hai. All right, dear. Let's come signal again on an easy level. There was only one MSQ in the instrumentation branch, and that is from the signal and system course, right? So let yt is equal to x of 4t. Let yt is equal to x of 4t. xt is a continuous time periodic signal with the fundamental period of 100. What is the fundamental period of the yt? So dear, x of 40 represents compression. Okay, and because it is compression, the time period will be compressed by what factor? By the factor of 4. So 100 by 4, answer is 25 seconds. Finish. So simple. It is the 25 seconds. Done hai?
Chalo, moving ahead to the next. I'm telling you, almost all questions of signals are on the easy level. Okay, let us go to the next question then. Consider the discrete time signal xn equal to u minus n plus 5 minus u n plus 3. So where will these signals be starting from? Okay, u n plus 3 will start from n plus 3 greater than equal to 0 to n greater than equal to minus 3, and u of minus n plus 5 greater than equal to 0 to n is less than equal to the 5. Okay, so if I want to draw them na, just for a very fundamental comparison, if I draw them, okay, I can draw u of minus n plus 5 first. दोनों को separately भी draw किया बोला तो you will be able to get the answer easily. And next is the what? Next is the u of n plus 3. Next is the u of n plus 3. Now, what is their waveform? U of minus n plus 5 will be 1, okay, for n less than equal to 5. Will be 1 for n less than equal to 5. Don't mind my drawing right now. बना देते हैं. Similarly, u n plus 3 is 1 for n greater than equal to the minus 3. Now, when I am going to subtract these two, this is 1 till minus infinity. What is the smallest n for which xn equal to 0? For which xn equal to 0. So, this is still minus infinity, na, first wala. So, minus 3 also, there will be 1. Now, this 1 and 1. Before this, it is 1 minus 0. Now, this is going to subtract. Look into this. 1 minus 1. This is the first and the smallest value of n. This is the first and the smallest value of n for which xn equal to 0. For which xn equal to 0, right? So the answer is minus 3, everybody. What is the answer? Minus 3. Let me remove this pole here, just a second. Okay, minus 3, correct. Chalo, so many of you are coming up with minus 3. Now I am able to see the comment box also. Okay, chalo, next question, guys. So this was the second one I got. Next. A continuous real valued signal xt has finite positive energy, and guys, this is a MSQ question. This is the only MSQ in instrumentation, and that is from the signal and system. Okay, and xt equal to 0 for t less than 0. From the list given below, select all the signal whose continuous time Fourier transform is purely imaginary. Tell me, guys, MSQ question. Okay, देखो, xt equal to 0 for t less than 0 and xt exists for t greater than 0, and that too it has finite positive energy, right? Matlab it's going to be square bounded, area under the square of the function will be finite. So, what is the condition that I have? Xt is actually real, right, as well as bounded, but it is not showing any symmetry because xt is 0 for t less than 0. It is real and in a sense asymmetric. It is neither even symmetric nor odd symmetric. Okay, now because xt is real, I will only take it to be real then. What is the Fourier transform, dear? If a signal is real, Fourier transform is said to be conjugate symmetric. Fourier transform is conjugate symmetric, so that x of minus omega is equal to the x conjugate omega. Correct? Is equal to x conjugate omega. Now, if I go option by option, dhyan dena. If I go option by option, option number says xt plus x minus t. So when I take its Fourier transform, xt ka Fourier transform x omega, x minus t Fourier transform we all know is x minus omega, because if there is time reversal, there is the frequency reversal also. Now, what is the x minus omega? According to the conjugate symmetry property, that is x conjugate, and whenever a complex number and its conjugate is added. So guys, listen. What is z plus z conjugate? That is equal to twice of x plus jy plus x minus jy. So jy cancelled. Acha, what is the difference between a complex number and its conjugate? So x plus jy minus of x minus jy, this will turn out to be 2jy. So whenever a number is added with the conjugate, it is real. We should all know it, but I'm just revising it. And when you subtract them, it is pure imaginary. So here you are adding it. So what is the answer? Answer has to be real. So A is not the correct answer. Which of the signal Fourier transform is pure imaginary? So A is not correct. Dityakshay, just check. I think आपने reverse कर दिया है. Okay. Now let me check with the B. Sir, what is the B? Okay. तो यही लिख देते हैं. ठीक है. यहाँ पे मैंने लिखा. So x omega plus x star omega. Okay. So this one is real. Now here j times x omega plus x minus omega. X minus omega is x conjugate omega. Okay. This is j times some real number, and hence this is going to be imaginary. hence this is going to be imaginary. ठीक है, अगला आ जाते हैं xt minus x minus t. xt is x omega minus x minus t, that is x minus omega, but I'm directly writing x minus omega is x conjugate omega. So it is like z minus z star, that is pure imaginary. That is pure imaginary. Okay, और d पे आ जाएंगे j into xt, guys ये typo error है, that is xt only. चलो ठीक है, अंडरस्टूड, दैट इज xt. सो xt फूरियर ट्रांसफॉर्म x ओमेगा माइनस x माइनस ओमेगा, तो दैट इज x कॉन्जुगेट ओमेगा. सो x ओमेगा माइनस x कॉन्जुगेट ओमेगा इज इमेजिनरी, तो j into j of something, like it is j into jy, that is minus y. So this one is real actually. Okay, so D is not the correct answer. The correct answer is B and C. Yes, Rityaksha. Okay. Okay. चलो डन है, डन है, डन है, डन है. So what is the correct answer for the question, dear? It is the B and C. MSQ question. MSQ question. It is the B and C. Moving ahead to the अगला question on the screen. Here it is. The next question on the screen. ठीक है. So that is what, this was the only MSQ. Now the next one, the impulse response of an LTI system is given to you. So the two questions are there today on the sinusoidal response. One we related with control system because transfer function given था, कहीं पे भी रख दो. Impulse response if it, sorry. Impulse response is given to me. So what is going to be the Fourier transform? That is the frequency response. Delta t 1 and plus 0.5 delta t minus 4. That will have the Fourier transform e power minus j4 omega because of the time shift property. Now the input frequency is 7 pi by 4. Right. So what is the value of h 7 pi by 4? What is the value of h 7 pi by 4? 1 plus 0.5 e power minus j4 into the 7 pi by 4. 4 से 4 cancel हुआ. 1 plus 0.5 e power minus j7 pi. Okay, so it is like 1 plus 0.5 e power minus j pi, which is always minus 1. तो minus 1 का power odd है तो minus 1 होगा. So 1 minus 0.5, that is 0.5. Okay. So dear, what is the magnitude and what is the phase? What should be the answer then? Okay, this is 0.5, which can be written as 0.5 e power j0. So the phase part is 0, magnitude is 0.5. So the output amplitude will be 0.5 and with the 0 phase shift, so 7 pi by 4 ही आएगा. So the correct answer is C. The correct answer is C. Clear everybody? Clear everybody? Because what should be the output, dear? What should be the output? It should be M, magnitude input multiplied by the magnitude of the frequency response, cos 7 pi by 4t plus phi. Plus phi. So this is what is the value of the magnitude. This is what is the value of the phase. Correct answer is C. Correct answer C. Okay. Chalo. Moving ahead to the next. Okay, next question. The Laplace transform of the continuous time signal is e power minus 3t ut minus 5. Okay, what is the Laplace transform of this? Take 4 options given, guys. Very, very, very simple. Direct Laplace formula question. So x of t is e power minus 3t. Sorry. इसको यहां लिख लेते हैं e power minus 3t. Some typo errors are there. U of t minus 5, which I can write now x of e power minus t ut minus 5 to apply time shift. Let me also make this as t minus 5, but I have to add 5. Okay, ut minus 5. ठीक है. Chalo. So Sona and Rityaksha says B answer. Aditi, I'm sorry, I'm not able to understand what is the context you want to speak here. So let us be specific to this particular session, please. Okay. So now this becomes e power minus 3 into minus 5. E power minus 15 को अलग कर दिया. E power minus of 3t minus 5 u of t minus 5. That is what is the signal xt. ठीक है. Now, if I want to talk about e power minus 3t ut, sir, what is the Laplace transform? E power minus 8t ut has the Laplace transform 1 upon s plus a with the ROC sigma greater than minus a, sigma greater than minus 3. Okay. Now, for this particular signal, e power minus 15, that is just constant. E power minus 3t minus 5 ut minus 5. To apply the time shift property. So 1 upon s plus 3 e power, what is the time shift? 5 unit to e power minus 5s. Right. Now look into this. Is there any displacement of the pole? ROC is majorly confined by the poles. Poles remain to be same. There is only a phase term introduced, and that is why the ROC will not be affected. And I think all the 4 options have similar ROC. So what is my answer then? s plus 3 तो आ गया. Okay, e power if I combine them, minus 5 सभी में common है, minus 5 लिया, then it should be s plus 3 upon s plus 3, sigma greater than minus 3. ठीक है, e power minus 15 है, so minus 5 into plus 3. ठीक है, e power minus 5 s plus 3 upon s plus 3. Correct answer has to be B. Everybody, the correct answer is equal to B. Yeah. तो आशीष, सोना, रित्याख्या, all says the correct answer is B. बढ़िया. ठीक है जी, the correct answer is the B. Moving ahead to the next question. Moving ahead to the next question. So these are the 5 signals questions that we have obtained. Okay, now coming back to a digital question. Already 4 questions of digital we solved earlier. This is another question. In the circuit shown, the initially binary content of the shift register A is 1101, जो कि लिखा भी है, and that of the shift register B is 1010. The shift registers are positive edge triggered and the gates have no delay. When the shift control is high, what will be the binary content of the shift register A and B after 4 clock pulses? After 4 clock pulses. बोल दीजिए इसका आंसर, सिंपल है ये भी. Okay, now let us say this is Q2. So this is Q2 का complement and this is Q0. Okay, and let me write down the shift register A content, which is Q3, Q2, Q1, Q0. But what is my serial input? My serial input is Q2 complement, and that is going to be XORed with Q0. That is going to be XORed with Q0. Okay, and this is initially 1, 1, 0, and 1. And after that, I have the B, whose content is 1, 0, 1, 0. 1, 0, 1, 0. All good. After this, I have 2 questions. One more control, one EMT. Then I'm done. है ना? So you can call the team. चलो guys. So देखो, Q2 का complement लिया. XOR you know different पे high, same पे low. Right? तो Q2 complement, 1 का complement 0, 0 and 1 का XOR. These 2 are to be taken care. 0 and 1 का XOR high. Okay, so MSB will be high because serial input enters the MSB. Okay, then right shift register. Okay, 1, 1, 0. Then again, 1 complement 0, but this is also 0. 0, 0, same. तो यहाँ किया 0, 1, 1, 1 forward. Then 1 complement 0, 0 and 1 का XOR high. 0, 1, 1 right shifted. कितना हो गया? This was initial. Right, तो 1, 2, 3. One more, 4 clock pulses. तो देखो 0 complement 1, 1 and 1 same. तो output 0 for XOR. 1, 0, 1 right shift. तो 0, 1, 0, 1. Now what about this picture? This picture clearly telling that the LSB of the shift register A will go to the MSB of the shift register B and rest is right shifted. So I have 1, 0, 1 and whatever is this will come here. Okay. Then similarly 1, 1, 0, this goes here. 0, 1, 1, this comes here. 1, 0, 1, this comes here. So 1, 1, 0, 1. 0, 1, 0, 1, 1, 1, 0, 1. Option number B आ गया.
I didn't catch that. Could you try again?
0, 1, 0, 1. 1, 1, 0, 1. Clear? So that's a decent question, we can say, with respect to shift register, because usually, they have kept asking one shift register. Okay, there's another shift register, but the second one is pretty simple. The actually main focus is on the shift register one only. So yes, guys, B. Right? Correct. Options can shuffle in the exam. Don't worry. For every student, options can shuffle. That's not a big data. Answer is B. 0, 1, 0, 1, 1, 1, 0, 1. Correct? Correct है, बिल्कुल सही है. चलो, so let's move ahead to the next one. This was also simple. Okay, so including this, I can say we have discussed around 5 to 6 questions of digital. Okay, control system questions we discussed, but one question we have got recently because I think plots था तो उस समय आया नहीं था. Magnitude and phase plot is shown in the figure. Match with the transfer function. Magnitude and phase plot is shown in the figure. Match with the transfer function. Match कर ले? Match with the transfer function. Match with the transfer function. Now please everybody see that at omega equal to 100 there is a resonant peak and there is a sudden drop of the phase. Okay, now one thing I will mention here, just a second. This is also e power minus 0.5 10 power minus 12 into s. Okay, if there was no exponential term, try to think like this. If there was no exponential term, okay, if you want to talk only about this, तो थोड़ा सा इसको यहाँ describe कर देते हैं. Okay, if you want to talk about the term omega n square upon s square plus 2 zeta omega n s plus omega n square, the standard second order transfer function, or if you convert to the frequency domain, the omega n square upon omega n square minus omega square, putting s equal to j omega, and then plus j 2 zeta omega n omega, and when you want to write down the phase function, numerator the positive real number hai, so directly denominator minus tan inverse 2 zeta omega n omega divided by omega n square minus omega square. So a very simple logic that when omega tends to 0 for low frequencies, phase will also be 0. But when omega tends to infinity, phase will be minus 180 degree. Okay, we have, once you study second order frequency response, you must be knowing this calculation. Or calculations you do, ठीक है, यहाँ पे solve करने की बात करते हैं. You can calculate the phase. Okay, देखो क्या होगा, omega tending to infinity पे denominator is negative, मतलब it's like second quadrant case. So minus of 180 minus tan inverse 0 will come. So minus 180 will come. Calculations आप कर लेना, ठीक है. So here what is the case if you are able to feel that. अरे बार बार वो erase हो जाएगा यार. This is S है ना. Here what is the case that if you look into the phase plot, dear, if you look into the phase plot, okay, it is going, it's not going to touch like this. It's going till minus infinity actually. It's going till minus infinity. There's a correction with the plot. That means at omega tending to infinity, phase is at least not minus 180. Yeah, if you talk about magnitude of phase, it is much greater. It is much greater. So definitely that added phase, minus and plus is just clockwise, anti-clockwise convention. If I talk about the magnitude of the phase, right, it is not 180 at the final frequencies, is much greater. Now why it is much greater? Because there is an additional phase term. So it is either A or C. It is either A or C. There has to be additional phase term. Now, अगर हम सोचें A and C both are having the same magnitude response, because the magnitude of e power j theta will be 1. Okay, so both are having the same magnitude response. Okay, ये भी 10,000 है. Okay, these are some typo errors. This is also 10,000. So both are having the same magnitude response, and because they have the same magnitude response, we cannot obtain the answer from this plot. Okay, what we can use from here? Okay, resonant peak, resonant frequency, but all the magnitude response for A and C, it is the same. So let us talk in terms of phase. Okay, let us talk in terms of phase. So if omega is equal to 100, resonant frequency की बात करेंगे, at omega equal to 100. If I take the omega equal to 100 dear, okay, then what is the value of, अगर मैं option number C से जाऊं तो e power minus j 0.05 into 100, that is e power minus j5. So what is the phase? That is equal to 5 radian. That is equal to 5 radian. That is 5 radian. Okay, that's just calculate करके देखा था मैंने, approximately 280 290 somewhere degree is coming. Okay, but whereas जब function होता है without the exponential phase, if I go back to the note, everything will be erased. I am not going. So actually at omega equal to omega n, the phase is 90 degree. Okay, actually if there is no exponential term, so 90 plus 280 somewhere around 370 380, and that is what is matching here. Okay, somewhere around 360 is given here. But if you talk about option number A, orally देखेंगे option number A, 0.5 10 की power minus 12 multiplied by omega equal to 100. So it is 0.5 10 की power minus 12. 0.5 10 की power minus 10. How much phase, sir? 0.00000000 something. Negligible, tending to 0. So if A was the correct answer, then actually, practically there is no effect on the phase term. Okay, then you should get the phase response very similar to what you get for a standard second order control system. ये S square है, ये S square है, ये S square है, ठीक है, थोड़ा typo error है, correct कर लेना, ठीक है. So A is not the correct answer then, because this has a negligible phase effect. So first I proved you yes there is a phase effect. So B and D cannot be correct. And which phase effect? Option number C. पूरा solve करने का जरूरत नहीं है, यहाँ से बन जाएगा, right? चलो, done है. Okay, and let's move ahead to the next one. All right. So only one question from EMT we have received. Okay, maybe there is only one question in the exam. The force per unit length between two infinitely long parallel conductors. Okay, what is the magnetic field due to an infinitely long parallel conductor? Right. At some point, okay, at a distance rho, okay, at a distance rho, the magnetic field is given by what formula? Mu naught, या flux density की बात करेंगे, mu naught into I divided by 2 pi rho, divided by 2 pi rho. Now what is the force per unit length between two conductors? तो यहां पे भी हमें कंडक्टर assume करना है, Okay, so let me draw that picture first. At this distance, suppose I have conductor. Maybe they are carrying the same current or different current, that is not mentioned. So we can take the different current also, no problem. Still no problem. But at this point, what is going to be the force? Yeah, force per unit length बोला है, तो directly let me write force per unit length. ठीक है? That should be given by how much? Mu naught I1 divided by 2 pi rho, the value of the field multiplied by the current carried by the other wire, that is the I2. In a sense, it is proportional to 1 by rho. Okay. In a sense, proportional to 1 by rho. Okay, so initially there was a gap of 2 centimeter between them, and then the force per unit length was 10. When the gap is doubled, okay, when the gap is doubled, the force per unit length will become half of the original value, which is 10. So the answer for the question should be 5 Newton per. 5 Newton. No, then I don't agree. Then this also has to be, I think there is a typo error. It cannot become 5 micronewton suddenly. So either this has to be also 10 micronewton per meter, because there is no change in the current. Okay. So only answer is, iska kuch typo error hua hoga. I will check it up. Maybe the data is missing here or there. Okay. ठीक है? Clear? ठीक है? Sir, done. Any questions? चलो. 10 micro. Acha, so then this may be 10 micro. Okay. Great to see Saket sir also live with us. This is 10 micro. This is 10 micro. So this becomes 5 micronewtons per minute. Okay, so there was a typo error here. Correct the units. It has to be consistent only. So great to see Saket sir joining us live in the comment box. So guys, maybe today you are seeing some of the faces like me, Ashu sir, MN sir, Ashto sir, Ishan sir, but there are several dedicated faculties, Saket sir, Sanjay sir. Unfortunately, due to some reasons, they could not join us live, but they are all there. The team of BYJU'S Exam Prep is always united, and the best one, you can say, providing you the complete solutions. And I think we have provided lots of solutions for the instrumentation. Yeah, I am done with my questions. So I think almost control system, digital signal, math, sab kuch ho gaya hai.
Yes, guys, we are visible on screen today, but many other faculty are there, like Sanjay Reddy sir is working on the solutions of analog circuits, EDC and other subjects. Saket is also available. So all the faculty are working. Maybe we few are seen on the screen. But hope you guys enjoyed the session and got the information. We have provided maximum number of questions what we received and solved it to clear your anxiety there. After exam, you must be having some doubts whether it is correct or not. So hope it is fine. So let's conclude with the difficulty level and with the questions we have seen, and the cutoff expected. These are important parameters again. So please guys, you also comment because we are going to tell our view. Maybe from your perspective it could be slightly different. Our perspective we are going to show you. Subject wise also we'll speak. Since I have seen analog questions, I don't think they are easy. At the same time, I don't think they are too difficult or twisted. The students who have some basic understanding and some practice is done, then only those students can do this type of questions, which are little lengthy in calculation. You must be, see, the students who have basic understanding of the op-amp working and MOSFET question also, the diode question is also there. So basic understanding of these devices and network basics. If you have these two things, then the solution is easier. That's why I'm saying it's not by directly seeing the question you'll get the answer. It's not directly formula based also. You have to apply what you know on analog and what you know on networks and combine them, apply and solve them. So that type of little lengthy questions. That's why I'm not saying them easy, but in fact they are easy because there is no much bigger twist except one question on op-amp. One question is there that is slightly difficult. I'll say, or that is slightly lengthy also. Reason is, as we just discussing whether we have not got exact question, but still Ashu Jangra and me are also just now discussing that the output asked is with respect to ground, but the voltage we are finding there is with respect to resistance. So I think it should be marks to all. That's what our conclusion is. Except that question, rest are all moderate, I can say, not easy, not too difficult. So what about other subjects, Rakesh? You
Sir,
discussed
common
some questions,
subjects are extreme simple, and from Not only from my point of view, for us it will be simple, but even for students' point of view, and especially when you compare it to the ECEE paper. Okay, common means I don't want to comment on network because Ashu sir and Ishan sir will comment. But if I talk about signal and system, very easy. Digital, easy. Right, only one decent question from shift register, just decent. उसको भी अच्छा नहीं बोलेंगे. Control system easy, only one good question from magnitude phase plot. That too, एक बार click कर जाएगा क्या करना है कर लोगे. But हाँ, वो एक ऐसा question था जो student को exam time में थोड़ा सा time ले सकता था. Rest all control system very easy. Maths is very easy. So mostly I'll call it as easy.
And sir, I guess network was very simple.
Network was very simple.
Sir, 3 या 4 question थे and that was too simple.
Exactly.
And analog is easy to moderate, we can say.
Analog was, yes, analog was moderate. I mean, it was good. I mean, analog questions were good because there was one op-amp question with capacitor. That question was again very good. And there is one more question in which I told you that ground is not available at the output point. So that question was again very, very good question. So let's discuss that question. Let's look at the complete data also. But till now, according to me, it's MTA. Because ground is not available.
Correct.
So again, that question was good.
Yes. And I think, sir, as far as I've come to analysis from the previous year also, analog is always little good for IN branch.
Yes.
Moderate to good questions, usually.
So that is why I'm little disappointed for electrical students because if you see only 2 questions from machines and because they don't get much core area in the instrumentation. But the common part, I think they must be able to do it because questions were quite straightforward. Some questions we have seen like analog question we have seen they are very good quality questions. Signal system we have seen good quality questions.
Signal system easy.
Signal system easy.
Control system also very easy. I think.
Control system easy. Direct question.
So one thing what I have seen is a very interesting point is that both Engg and this we can say IN branch, the aptitude portion was completely same.
Yes.
The aptitude questions also and the verbal ability part. And we are getting little confused because when I'm asking where is the Engg branch aptitude questions, we are getting the same questions. So that was a little surprise to the
maybe same slot.
Maybe same slot.
Sometimes IIT do this. Okay, so Engg and IN similar. So guys, this analysis we talked in the beginning, a very small highlight and important one is a number of MSQ, just single one, and that too very simple. Signal and system ka question hai, Fourier transform ka. Signal and system, Fourier transform, fundamental question. If you know the property, of symmetry, if the signal is real, then what is the Fourier transform? You are able to solve that. Nothing much in that. Okay. So next, what is that? All right, yeah. So let's talk about the main thing that we expect, as per our discussion. So looking into the last year trend, the cutoff suddenly jumped. This also will be higher side only because the paper is simpler level, right? So, sir, what do you say, Ashu sir?
I do agree with these numbers. I do agree with these numbers. Year on year, it is increasing. Maybe for the reason EC electrical students are also joining it,
because of the two paper combination.
Right. Where IN students alone are writing, then cutoff was little lesser. And compared to the level of questions, as Rakesh is saying and Ashu Jangra sir is also saying, the easier questions except analog are moderate or little lesser than moderate, except 1 or 2 questions. So we can conclude that this 43 can be expected. If not plus or minus 1 mark this side or that side.
Correct.
40 plus is damn sure.
Yes.
So what can be the safe score if we can little bit elaborate? What can be the safe score? For example, if somebody wants under 100 or under 200 rank, I think it should
Sir,
be
I think
60 plus.
yes, 60, 70
70
plus.
plus.
70
Under
plus.
100, I guess 70
Yes,
plus has
70
to be
plus.
there.
Because the number of students are again less.
Again
sir.
less,
So that's why.
So this is what, guys, is the subject-wise distribution. If we see, okay, so there is no question from process control.
It is surprises. 22
Surprises.
and 23. Analog is same. This is something surprising. 7 marks. No, is marks or questions?
Sensors in industrial.
Question distribution. 7 questions were there earlier from this IN core subject.
And this time only it is 2.
Only few.
Okay, this is very surprising. Measurement is on similar basis. Communication gone down. Analog on the nearly similar trend. Optical similar trend. Process control 0 hua, but that is always maximum 1 question. EMT 1. Machines 2. Mathematics 9 question. General aptitude 10 questions.
So these questions are adjusted with these 2 subjects and maybe.
Yes, correct. So the weightage also for network control and digital you see increased and with easiness also. So benefit.
I think it is little more inclined towards EC and electrical
Correct.
students rather than the core IN branches. Because
Yes,
the core has been having less questions this time.
All right. So this is okay. I think ye to. But I think that's it, sir.
Yeah.
Okay.
So this is what from our side, guys. So we gave our best to give you all the solutions. We got the questions also for maximum questions. We tried our best to give you the answers as well as the solutions possible to justify the answers. Hope you all enjoyed this. Stay with us and keep getting more information even after the gate. So these sessions, analysis sessions, we do for two reasons, as we always say. One is to clear the the curiosity of the students who are writing the exam after the exam, to know the answers whether they have corrected or correctly written or not. And second is for the next year aspirants to see how the level of questions, how the pattern and how difficulty and what are the ways to solve these questions. These are the reasons we do this. We wish all the very best for the students who wrote the exam, and all the very best for the next year aspirants as well. Even whether the exam is going good or not, or for the next year aspirants also, we are there always. Even after the GATE exam, we will be conducting few more sessions useful for you, where to focus more on to settle well in your life. Okay.
Amit, I think Amit has one more question. So where to send? You can send us on the Telegram groups, either in our personal groups or the official groups of BYJU'S as well.
Even Naveen sir is also
correct.
commenting you that you can send them in Telegram group. Our faculty are there, our subject matter experts are there. Even that question is not discussed here, you will get the solution there as well.
Now guys, already some post-gate guidance sessions have already started in this particular YouTube channel, right? You can access those also previous week, because ECEE paper was over. So we have given some post-gate guidance, what to do after the GATE examination, right? And many more will be coming up. So if you're ECEE students, ESE non-tech is also going on, ESA technical syllabus is going on. So lots of things other than GATE are going on. Like for example, tomorrow I have a session on BARC. We'll talk about, the BARC 2023, how it is similar to GATE, why a GATE aspirant can think about BARC. So not only BARC, guys, similar such sessions will keep coming. So it's all about post-gate guidance now. So stay tuned to BYJU'S Exam Prep. And
it is very important. Always don't target for a particular exam. Preparation should be a journey. These exams will come in your way. So you keep cracking these exams, keep writing these exams. So you'll crack, if not GATE, BARC, if not BARC, some other. Otherwise, next year it is there. So it should be a journey.
Yesterday only I made a short video. And that's what I felt. That is why I made that. Usually when students does not do the GATE exam much good. So this time, from February to March, April, May, mostly they are just thinking what to do, right? So of course, everybody needs some time. Okay, but mostly I have seen that even those who want to prepare for another exam or next GATE exam, वो active होंगे April, May के बाद. So if you want to make a decision, okay, take 10-15 days of buffer time. But why do you prolong to April, May? And this has happened with several students as far as my experience concerned, right? So जो भी decision करना है, if your exam is good, start preparing for interview. If not good, start preparing for other exam. Bas.
Start preparing for subject. That's it. That exam can be anything. So it can be GATE, ESE, BARC, ISRO, whatever the exam is. You start doing this. Don't stop. Just have some pause. That's help you always, right?
Even some of the premier institutes like IIT and ISC, they have their own separate written test also if the number of candidates are too high. So you cannot be in a relaxed mode. 1 or 2 days you can relax, but at the same time you have to comply with the sessions we are bringing, like post-gate guidance. That these are very important, because this is just one step of your preparation after appearing in the examination. Now you have maybe group discussions also, interviews also, maybe some written test also, and whatever you have gained in up to this preparation, you can use it in the BARC, ISRO, and so many other PSUs
like
also.
Last year, I remember HPCL and BHL exam conducted in somewhere around October, November, right?
Same month.
So आपको पता है कि at least 3-4 separate exams you will have from some PSU. Almost it is going to come. Worst case हो गया तो we don't say, but most likely they are going to come. So keep prepared.
So
don't wait till October.
It is like giving you 4-5 chances to clear any one of the exams.
Yes.
So thank you so much, guys.
Thank you.
All the best.
Thank you.
Stay safe. Take care of yourself.
And stay connected to BYJU'S Exam Prep. Thank you.
Subscribe the channel.
Thank you.